Alright, let me set the context for the video. In this video, we're going to discuss 10 ways to deploy your application. Now this application could be a simple React website. It could be slightly more complicated of a front end using NextJS. It could be a backend in Node.js, Golang, Rust, or it could be a containerized application, which could literally be anything, whatever you have containerized. How can you run it on the internet? Some of these are beginner friendly ways. For example, how do you deploy it on Vercel? Some of these are scalable and price effective ways. For example, either serverless or hosting it in a Kubernetes cluster. And some of these are completely dystopian ways you should probably not host your applications. For example, hosting it on your local machine and exposing it on the internet, or hosting it on a decentralized compute. I don't think we're there yet. We'll discuss the pros and cons of each and one of these. We'll deploy our application in all of these 10 environments. And I'll share my insights on what I think are the right ways to deploy your application based on the scale that your company is at. Without any further ado, let's get right into the video. Alright, this video is going to be divided into a few parts. Firstly, we'll create a very simple React application, a pure front-end application. Then we will deploy it on Vercel. That's the easiest place you should deploy your application. Then we'll understand how can you get a virtual machine on DigitalOcean, AWS, GCP, and deploy your front end over there. And lastly, we'll arrive at an optimal solution, which is CDNs, content delivery networks, and object stores. This is probably where you want to deploy your pure front-end application. By pure front-end, I mean an application that's written in React or an application that does not use server-side rendering. After that, we'll be creating a Next.js application that has both a front-end and a backend. But whatever logic applies in this section applies to a Node.js application as well. Golang, Rust, Java, whatever backend you are using, you can use one of these ways to deploy it. We'll first understand and look at a cheaper serverless alternate. This is how you might want to bootstrap your backend or deploy it. Then we'll look at virtual machines, which is the same as this section right here. Then we'll be self-hosting the application in our home lab, which literally means if this is my Mac machine, all the traffic on the internet will be coming to my machine. My machine is what will be handling it. And lastly, we'll look at some cloud specific auto scaling technologies, things like auto scaling groups in AWS that let you scale your backend or, front end application that uses server side rendering. This is great, but at the same time, if you really want to reach optimum, you should containerize your applications. So lastly, we'll be containerizing our app and we'll be first deploying it in a Kubernetes cluster. We'll discuss a little bit about what Kubernetes is and how do you deploy an internet facing application over there. Then we'll be deploying it on a decentralized compute. This is something you probably shouldn't do. It's a little immature right now, but it's cheaper than all cloud providers because here there's a market for you to get compute from other people all around the world in a decentralized fashion. Lastly, we'll be looking at an open source version of Vercel, Coolify. There's no reason for us to look at it. It's just that if you are really ingrained in the Vercel ecosystem, but you feel Vercel is expensive, which of course it is, you can host an open source version of Vercel. It gives you all the benefits of that Vercel gives you, things like direct integration with GitHub. And it's much cheaper. It's self-hosted, so you can deploy it on your own infrastructure. Without any further ado, let's get into the first section. Let's create a simple React application. Step 1, let's initialize a React application. Step 2, let's open it in Visual Studio Code. Step 3, let's install all the dependencies. Step 4, let's try to run this locally, see if it works right. Step 6, let me edit this and create a very simple front-end only application. I've created a very basic structure of my application. It has 4 components it needs to render. A nav bar that should render here at the top. A hero section that should just render a video over here. A new courses section that shows a list of courses that might be coming in the future. And existing courses that shows a bunch of existing courses. We need to add styles to this to make it a little bit prettier. Also need to, make sure it looks better. So let's add Tailwind to our project next. Let's see if Tailwind works correctly or not. Seems like it. This is underlined over here, and I'm using a Tailwind class called underline to make sure the final component, this text right here, has an underline below it. Now let me finish the whole application. Right, I've created the navbar component, which is this thing that you see right here. There's 100x devs written over here. There are 2 buttons here on the right. What is 100x devs, you ask? 100x devs is a premium cohort that I run once every 6 months. It's a live cohort where we learn about web development, DevOps, system design, a bunch of other auxiliary things, whatever is needed for you to become a good web developer. It's highly project driven, extremely aggressive, has TA support, but expects you to give in a lot of hours to become a great full stack engineer in a span of 6 months. If that sounds interesting, the website that we're deploying today is going to be a landing page for the cohort. You can either buy one of the existing cohorts or pre-register for some of the upcoming cohorts. That includes the next WebDev cohort 3.0 or the Web3 cohort that we'll be launching very soon. Now back to the video. If you want to look at the code for the nav bar, it's pretty straightforward. I've defined a top level div which has a small border at the bottom. That's what border B stands for right here, this border. I render 100x devs on the left. I render 2 buttons on the right. How do I position them on either sides of this specific div? I do that by using flexbox. I have justify between class that I'm using here, which means justify the space between the 2 children of this top level div. This is the top level div. This is the first child that will be on the left. This is the second child that will be on the right. Now let me finish the rest of the application. All right, halfway through, I realized I wasn't recording. I haven't done too much. I've added 2 card components here for the new courses, 2 card components here for the existing courses. I'm struggling a bit with this model that appears when you pre-register or click on this button. I'll just fix this and then we'll look at the final product. We'll also go through the code really quickly. All right, we're done with a basic version of the application. We have a nav bar over here. We have a hero section. We have two set of new courses that people can pre-register for. We have two existing courses that when someone clicks on it, they get redirected to the course page. We need to now deploy this application on the internet. This is a purely front-end application, by which I mean the pre-register submit button right now does nothing. Eventually, when we move to Next.js, we will add some backend functionality. Let's understand how React works under the hood a little bit. Let's understand how you deploy React applications, and then we'll one by one deploy it on various platforms. All right, one thing you need to know about React is that React is just a framework. It in the end spits out HTML, CSS, and JavaScript files. These are the things that you have to deploy on the internet. This thing on the left is just to make the developer's life easy. I repeat, the .jsx files, the .tsx files, the components that you write. This is just for the developer so that they can write reusable code. If I go back to the code over here, you will see this model component that I've written, or if you go to the components folder, all of these individual components that I've written, button.tsx, this isn't something your browser understands. It's TSX files. Browsers are not supposed to understand a file which has both JavaScript and HTML. Browsers can only understand HTML, CSS, and JavaScript files, which means okay, when we're deploying, this is what we need to deploy. We need to somehow convert our React code over to HTML, CSS, and JavaScript. How can you do that? Thankfully, most frameworks that you use to bootstrap a React application, for example, here we have used Vite, give you a command that lets you transpile, convert TSX files into JavaScript, as long as you don't have a bunch of compilation errors, which I do. So let me quickly get rid of them, and then let's compile our code. All right, there we go. I've gotten rid of all the compilation errors. Now, if I look at the original code, it has a source folder, it has a readme file, a bunch of things. But if I run the command npm run build, you will see a new folder is generated called dist. Dist stands for distribution. This is what you distribute out in the world. If you look at the command logs, it says index.html file is created, a CSS file is created, a JavaScript file is created. Now, if I delete all of my code base, if I delete all the files from here to here, that is totally fine. As long as I have this dist folder, as long as I can distribute this dist folder, my website can be deployed on the internet. I don't need any of the original source code. React is just a framework. All of these files that are written over here or that you have written eventually get converted into this dist folder. This dist folder has a bunch of files that we now need to distribute, that we need to host on the internet. Let's see how you can do that. A bunch of frameworks hide all of this complexity from you. Over there, you don't even need to worry about converting. They convert your JavaScript code into TSX, or sorry, your TSX code, your JSX code, your React code over to HTML, CSS, JavaScript themselves. Sometimes you have to do it by hand yourself. We'll discuss both of these approaches. Let's get into the very first way to deploy your application, the simplest way to deploy any React application on the internet today. All right, the easiest way to deploy your application is to use something called platforms as a service. Vercel is the most popular one here. Netlify is another one, pretty much lets you do the same thing. If you go to vercel.com and sign up, you will see a dashboard that looks like this. Here, you have an option of importing any GitHub repository of yours, and it will automatically detect that it's a React application, automatically deploy it on the internet. You can attach your domain names to it as well. Let's look at all of these steps one by one. Step 1, go to Vercel and sign up. Step 2, push your code over to GitHub. How can you push your code over to GitHub? Make sure you're first signed in on GitHub. GitHub is a place where you can push your code. Click on new over here. Let's name this project landing page React, and let's make it a public repository. You can also make it a private repository if you don't want your source code shared to the world. Vercel would still have access to it as long as you give it access to your GitHub. This is my repository. Let me push my code in here. To recap the steps, I first initialized a GitHub repository here by running git init, a Git repository. Then I added all the files in this specific commit. Then I committed all my changes by running git commit -m init. Finally, I had to push my code over to GitHub. The way to do that is first copy this URL for your GitHub remote, run the command git remote add origin, and then paste your origin over here. And then lastly, git push origin, either main or head, would push all of your latest commits over to GitHub. If you don't understand this, go through a very basic GitHub intro course. Should be pretty straightforward. After I refresh this, I see all of my code now present on the internet. Other people can see it as well. Now I need to deploy this over the internet. How can I deploy my code? If you go back to Vercel, click on add new, click on project. It lets you import your Git repository. This will happen if you've linked your GitHub to Vercel. I've already done it. You might have to do it. Once it has loaded my projects, I can click on import on this latest project that I just pushed to GitHub. It automatically understands that I used Vite to create my React application. I can leave the default settings here. If you have something extra, for example, if you use 𝗟𝗶හි𝗸𝘀, a different monorepo framework, you might have to change a few settings here. For us, it's pretty straightforward. Click on the deploy button and it will start your deployment. And there you go. It automatically understood that it was a React application. It was able to deploy it. If I click on continue to dashboard over here, it gives me a live link as well. If I go to this live link, my website is deployed on landing page react steel.vercel.app. It's the same as the thing that I had locally. That's as simple as deploying a React application on the internet. If you think or / are curious, okay, how does Vercel work, Harkirat? Number one, I have a video that takes through a very beginner friendly first principles approach of building something like Vercel. You can also look at the code base of Coolify, which is an open source version of Vercel. We'll also be looking at that towards the end of the video. A good question you might have is, Harkirat, how can I host this on my own domain name? And the answer is pretty straightforward. Go to godaddy.com or squarespace.com or googledomains.com. These are websites that let you buy and manage domains. I personally buy most of them on Google Domains, even though Google Domains is not a thing anymore. I think they sold this to Squarespace or were already a wrapper on top of Squarespace. So you might have to buy this domain on Squarespace. As you can see, I own all of these domain names and one of them is 100xdevs.com. If I click on manage and click on DNS, this is the same thing you have to do on GoDaddy as well, or whatever DNS provider you're using. Click on manage custom records and then just add a new record that stands for wherever you want to deploy your application. For example, I want to deploy this at react-1.100xdevs.com. This is where I want my application to be hosted. I can select the type A over here and the value over here. Vercel gives us, it's a constant value for everyone. If I go to the settings section, where am I? On Vercel, on my specific project. If I click on settings, click on domains and add a domain here called react-1.100xdevs.com. It tells me, okay, hey, please add a CNAME record to react-1 that points to this value. So if I go here, the value needs to be CNAME. It is not an A record, it's a CNAME record. That's what Vercel told us here. And what is the value of this? It's cname.vercel-dns.com. If I click on save now, all I have to do is wait for a few more minutes and my application will automatically be deployed on react-1.100xdeps.com. They will also generate an SSL certificate for you. What is an SSL certificate? An SSL certificate basically gives you something like this: HTTPS. If you don't use an SSL certificate, you will see HTTP over here. Your end users might see this website is insecure from time to time, and hence you should always either create them yourselves or use a service like Vercel that just generates them for you. Let's wait for this to deploy. And after some time, as you can see, we have checkboxes over here. If I go to react-1.100xdeps.com, I see my landing page deployed over here. It's that easy to deploy a React application on the internet on your own domain name with an SSL certificate. The only downside here is that Vercel is very expensive. The reason they give you so many benefits, the reason they're so easy to work with, is because they're also very expensive. They're working actively on that because they're being called out a lot now. But you might want to move away from Vercel if the pricing structure does not match for you. The other benefit that Vercel provides you is automatic GitHub integration. If I make any changes to my repository, if I change my code even a little bit, for example, let's say I go to app.tsx here, directly on GitHub, I can go locally and push it here as well. I can directly edit on GitHub as well. If I click on edit, and let's say I remove this existing courses component and commit my changes. If I go back to the Vercel dashboard, go back to my project, you will see it started to build again. It gave you something called continuous integration. It is continuously looking at your GitHub repository, and whenever there is a commit on your GitHub repository, for example, this update app.tsx was added by me, it automatically deploys my code. Now it failed over here. Can you guess why? It failed because if you go to app.tsx, I am importing existing courses and not using it anymore. So I need to remove this import as well. Commit again. I can also confirm this in the build logs. If you look at the error, you can just go to this deployment section over here. Look at the second error that was happening and it says build command failed. If you expand all the lines, it will probably give you something along the lines of why the build failed. All logs. It does not give me anything useful, but if I run npm run build locally, I'm pretty sure almost sure that was the error. We can also confirm by looking at the most latest commit. If you look at the most latest deployment, which just happened after I removed the import as well. I repeat, I just removed the import in the latest commit, right? If I go to the latest commit over here, what has happened? In the latest commit, I removed this extra import because I assumed this was what was failing the build. I can also run this locally to confirm. If I locally run npm run build, let me quickly show you. If I go local, if I go to app.tsx, if I just remove this, save my file and run npm run build, you will see the build fails. But if I remove this as well, then you will see the build succeeds. And hence that's the same change I made over here. The thing to know is, okay, on every commit, first I just removed the component, it tried to build it, gave me an error. When I fixed it, it tried to build it again, and this time actually succeeded. The thing to know is, okay, Vercel is continuously deploying your code. That is what CD stands for. CI/CD mein CD stands for continuous deployment. That is exactly what Vercel is providing you over here. You can also confirm by going to the website. If I go to the website, notice the last section over here is gone. Since I removed the last component, this component right here, the existing courses component, the website also doesn't have it. This is how you continuously deploy your code as you make more and more changes to it. Cool. That is what Vercel gives you. This is a great start to deploying your first application. What are we going to discuss next? We're going to discuss how can you deploy it on your own machine now. How should you not deploy front ends? You should not deploy them on your own machines, but nonetheless a great thing to know. It will also come back later on when we reach the backend part. Let's get into the second way to deploy your frontends. All right, deploying to a virtual machine. If you haven't already heard of it, there are many cloud providers out there. For example, AWS, which stands for Amazon Web Services, GCP, which stands for Google Cloud Platform, Vultr, DigitalOcean, so on and so forth. The primary offering of all of these cloud providers was something called a virtual machine. Now today they do thousands of things, but the very first, primary use case that they came up with was a virtual machine. What does the name virtual machine tell you? Pretty much means if this is the world map. Amazon has rented a bunch of data centers. I repeat, Amazon has a bunch of data centers all around the world, and you can create a small virtual machine over here. Why does it say virtual machine? Because it isn't really a single Mac machine, Windows machine over there. There's a very big pool of compute somewhere, a lot of RAM, a lot of CPU, a lot of memory. They just create a virtual layer on top of it. And that is the machine that you have access to. It feels like you have access to a machine on the other side that, is a physical Mac machine that's present there. But there's actually a, very big compute out of which they just cut out some specifications for you. For example, 2 CPUs, 4 GB of RAM, and that is what you get access to. Now you can deploy your application over here. You can, number one, get a VM. Number two, deploy your app over there. The things that the VM provides you is, number one, it provides you with, a machine. VMA, M itself stands for a machine. Number two, it provides you with something called as a public IP. This is one of the biggest reasons that you cannot host this application on your own Mac machine. If everyone got access to a public IP, then you wouldn't need these cloud providers at all. But unfortunately, that is the hardest problem here. There are limited public IPs in the world. So a lot of these cloud providers buy them off and then eventually rent them to people like us. If everyone would have been able to get a public IP, you could have just hosted this application on your own machine. Can you still do this? Yes, we will discuss this towards the later end of our video when we understand about tunneling. But for now, what do we have to do? We'll get a virtual machine and deploy our React application over there. What cloud provider would we be using? We'll be using AWS, but it really doesn't matter. You can choose any cloud provider of your choice. In fact, throughout the video, we'll keep switching between various cloud providers. Irrespective of what cloud provider you use, you will have to follow 4 steps over there. Number 1, get a virtual machine. Number 2, install Node.js on your virtual machine. Number 3, copy over your source code to the machine. And number 4, start your application either on port 5173 in dev mode or on port 80 in production mode. Let's get into all 4 of these steps one by one. Step 1 was creating a virtual machine. Now, if you are able to sign up on AWS, you will see a dashboard like this and the section called EC2, which stands for Elastic Compute 2, is where you want to go if you want to start a virtual machine. Click on instances and an option called launch instances on the top right lets you create a fresh virtual machine. Give your virtual machine a name. Select the operating system you want deployed there. I'm going to install Ubuntu. Select the instance type. Micro means a really small machine. You can make it bigger or smaller. Let's go with small for now, which has 1 vCPU and 2 GB of memory. Key pair, ignore this for now. This is the ideal way to connect to your virtual machine. But for now, thankfully, AWS lets you connect it to it directly through a website. So we'll probably just do that. Ideally, you should create a key pair. Network settings, This is what's called setting up a firewall rule of your machine. Since this is an internet facing application, we should allow HTTP, HTTPS traffic. We should ideally allow traffic on port 5173 as well if we want to start the application in dev mode. For now, just HTTP traffic is good enough. Lastly, how much space do we need? 8 GB is great. If you click on launch instances, I'm going to proceed without a key pair, but ideally, as I said, a better thing to do at this point might be to create a key pair and use that to connect to your machine. Once I click over here, you will see I have a fresh instance called React app. If I remove this filter on the top, again, you will see I have a bunch of machines, some of them already running in the past. The one that I've just created is this React app machine right here. It is pending, which means it hasn't yet started to run. We have to wait for a few minutes for the machine to start. As you can see now, the machine is running and I want to connect to it. What was step number 2? Step number 2 was installing Node.js on the machine. If you want to install Node.js on the machine, you need to connect to your machine. How can you connect to your machine? Click on the specific instance you want to connect to. Click on actions and then connect. Connect using EC2 instance connect. This is the browser way to connect to your instance. Ideally, you should use key pairs. As you can see, I am now connected to my machine that's running somewhere else. I can run bash commands over here. What was step number 2? Step number 2 was installing Node.js on the machine. How can you install Node.js on an Ubuntu machine? There's a very famous blog post, nvm install on Ubuntu DigitalOcean, which I always follow. It's a DigitalOcean blog post that shows you various ways to install Node.js on a machine. The way we'll use is this option 3, installing Node using the Node version manager. Let me open this on the right. Let me open my instance on the left. What is the first command you have to run? This is the first command you have to run. Harkirat, not this? No, this will just print the bash commands that you want to run. What do we want? We want to print them and pipe them to bash, which is why this second command is what you want to run. If you run the first one, it'll pretty much do nothing. Then it asks you to source .bash rc. It's basically put some code in a specific file that always runs when your terminal starts. Since my terminal hasn't just started, it started like a few minutes ago, I need to source this file. I can also just close this tab and reconnect. Then I wouldn't have needed to source the file. Now I can install Node. If I run nvm, it shows me nvm does exist. I see some log that comes out when I type nvm. I can type nvm install node to install Node.js on this machine. That was step number 2. How do I know if Node.js is running? If I type node over here, I can see a node REPL. If I press command C twice, I exit out of the REPL. What's step number 3? Copying over the source code. Where was the source code again? It was on github.com/𝗟𝗶හි𝗸𝘀/ landing page React. So I can copy this and run the command git clone the repo URL. Then I can go to the repo, cd landing page. If I press ls here, it shows me all the contents. If I press npm install, it installs all the dependencies. And now is where you are faced with a dilemma. Should you run npm run dev and just visit your machine's IP:5173, or should you do something else? If you remember, what did I say a while back? Okay, your React code eventually gets converted into HTML, CSS, and JavaScript. And this is what you want to serve in production, which basically means you do not want to run npm run dev. You can still run it. You will still see a website on the other side, but it will be in dev mode. It will not be built correctly. By built correctly, I mean it will not be compressed. You will see a bunch of dev data that you shouldn't, and hence you should first convert this to HTML, CSS, and JavaScript, and that is what your server should be serving. How can I convert my source code in this source folder into HTML, CSS, and JavaScript, you can run npm run build. I repeat, the command to run is npm run build, and that will spit out a dist folder. This dist folder is what I now want to serve. If I go to the dist folder, I see an index.html file here. This index.html file is what I want people to be able to see when they visit my website like react2.nextdevs.com. How can I serve this file? How can I serve the CSS files that exist here as well? The npm run build command created the index.html file. It also created a CSS file. It also created a JavaScript file. How can I serve all three of them? There are a few ways. You can use Nginx, which is, it's a bunch of things, but it also lets you create an HTTP server that serves these files statically. What does static file serving mean? Basically means serves all of these files as such. If you send a request to react2.nextdevs.com, I repeat, if you send a request to, let's say, react-2.100xdevs.com, this request reaches your AWS machine. You can run Nginx, which is a pretty common HTTP server, reverse proxy, a bunch of other things, which can forward your request, or not forward your request. It can simply statically serve all of these files. Or you can use a library like serve. I repeat, if I run npm install -g serve, if I globally install serve, and then I run serve, it will start to host these files on a specific port. I repeat, on port 3000 now, this folder is being served. What does this folder have? This folder has my index.html file. So if I go to this machine on port 3000, I should see my website's index.html file. I should be able to literally see the website there. But we did not open the firewall rule on port 3000. If you remember, we only opened the firewall rule on HTTP and HTTPS. If I go back to my instances, go to the React app instance and click on security over here, you will see we only added port 80, port 443, and port 22. I added port 5173 for debugging, ignore that. But 80, 443 are the only ports that we opened. I have not opened 3000 over here. I can if you want. If I go to this security group right here, what is this security group? It defines a bunch of inbound rules to your machine. Kya is machine mein only these ports are open. Right now there aren't a lot of ports here. If I add port 3000 here, then I can visit my website. If I type serve over here, and if these files are being served on port 3000, if I do want to visit them, if I do want to visit this website on the internet, I will have to add a security rule here. I will have to open port 3000 to the world. Let me add a new rule over here for port 3000. Custom TCP, port 3000, allowed from anywhere. If I click on save rules, and now if I go to my machine's IP, what is my machine's IP? My machine's IP is this IP right here. If I go to my machine's IP, :3000, I see the website being served over there. How is the website being served over there? Because I am running an HTTP server here. Serve is nothing but an HTTP server that serves all of these files statically. All the files that exist in this folder, index.html, assets/index.js, all of these files, if you want to serve over the internet, you can use Nginx as I said, or you can use this library. The name itself of the library is serve. If I go here and click on inspect network tab, you will see if I go to, the IP of the machine :3000, I get back, I hit a bunch of endpoints. The first one returns the index.html file to me. So this index.html file and all of the other things over here are being served from this machine because I ran the command serve over here. What is the serve command doing? It is just statically serving all of these, images, index.html file, and my CSS and JavaScript assets. Harkirat, how can I connect this to my own domain name? How can I make sure if my friend goes to react2.100xdevs.com, they're able to see this website? Again, the steps are the same. You have the IP where you want your domain to point. You can go to your domain provider, GoDaddy, Squarespace, or for me, it's domain.google.com. Select the specific domain you want to update. Click on DNS, manage custom records, and add another entry for react-2.100xdevs.com. The type this time will be an A record and just paste the IP over here. Click on save. And now if I go to react-2.100xdevs.com, it might take some time to propagate. Hasn't worked yet. Let's wait. Oh, there is nothing running on port 8080. Actually, that might be it. React-2.100xdevs.com :3000. Where is it running? On port 3000. If I go here, I do see the website. It is ugly. It has :3000 here. It has not secure over here. So we're not there yet, but we're getting there. At least it is hosted on my specific URL on port 3000. The next step is, Harkirat, how can I serve this on a better port? How can, if the user goes only to react-2.100xdevs.com, they're able to see my website? And the answer is you can just serve the application on port 80. I repeat, you can just, when we ran serve, it gave it a default port of port 3000. If I run serve-p 3001, it will start to run it on port 3001. What is the default HTTP port? If I go to react-2.100xdevs.com, where is this request going? The default HTTP port is port 80. It is just it. There's something you need to know, which means I need to start my application on port 80. But 80 is a very provisioned port. Not everyone has access to this. If I run this, it'll tell you fail to serve, error, permission denied, port 80. Our machine is not giving the serve library permission to start on port 80. How can you give the serve library permission to start on port 80? You need to install serve as the super user. I repeat, you need to first install Node.js as the super user, then install serve as the super user. Sudo apt update to update your registry on this machine. Sudo apt, you can also install nvm, npm, that route works as well. Whenever you're installing nvm, install it as a super user. That is what sudo stands for, super user do. Or you can simply do sudo apt install Node.js. That should install Node.js on this machine. I already did that a while back, which is why it took less than 2 seconds. And now I can run sudo node. I can run node as the super user. I can run npm as the super user. And since I can run npm as the super user, I can also run sudo npm install globally serve. And now I can run sudo serve-p 80. Now I'm running serve as the super user. Now I have access to start it on port 80. As you can see, it started on port 80. If I now go to react-2.100xdevs.com, I see my application. I don't have to give an ugly :3000 at the end. That is how you deploy an application to an EC2 machine and connect it to your domain. The steps remain exactly the same if you deploy it to Vultr, deploy it to GCP, DigitalOcean, doesn't matter. Same steps. Firewall rule adding might be different on every provider, but you need a machine, you need to install Node there, you need to start your application, connect it to your domain name, you're good to go. What is the last thing that's left? Not secure. We have not added an SSL certificate. How can you add an SSL certificate, Harkirat? There are various ways. You can buy an SSL certificate or you can get one for free. The easiest way you can do it is using something called certbot. If you Google certbot, you will reach here. This will show you a way to install an SSL certificate on your machine. I'm not doing it just for kicks. If I'm being honest, I'm happy to do this as well. It's not too difficult to do. But if you try two things, I repeat, if you Google two jargon right now, number one, Nginx as a reverse proxy, and number two, certbot, it should take you less than maybe half an hour to figure this out and do this yourself. So leaving this as an assignment. We're done with the second one, which is deploying your application on a virtual machine. By the end, we have something running on react2.100xdevs.com. The only thing that's left is attaching an SSL certificate to it. For this, you can just use certbot and do it. Or if you want to make your life a little bit easier, you can use Nginx and certbot, or Apache and certbot. Either is fine. And it should take you less than half an hour to figure this out. Leaving this as an assignment, let's move on to the most ideal way to deploy your application. How you should deploy a React application, both for cost purposes and for scaling purposes. The next section is better. Why is this not good for scaling purposes? Because you have a single machine. You have a single EC2 machine. If you have 1 million users, this machine cannot handle all the load. What is the thing that can handle all the load? What is the thing that can scale almost infinitely is what we'll discuss in the next section. All right, let's quickly learn two new jargons, object stores and CDNs. Object stores, as the name suggests, lets you store a bunch of files. In the end, what do we want? We want an index.html file, a few CSS files, and a bunch of JavaScript files, images, so on and so forth. All of these to be served over the internet. Until now, we have tried two approaches. Approach number one, we used Vercel. We had zero visibility to how things were being deployed. We were just happy it was deployed. What is the downside in Vercel? It will get expensive. You will not be able to handle this at scale. It will be like a lot of money unless you have a lot of money. Vercel's pricing is a little weird. What's the second way to do it? Your own machine. We deployed it on EC2. Here we have full ownership. But what is the downside? It does not scale. It does not scale up beyond a point. You might say, Harkirat, I will start 5 machines. Sure, but it won't scale infinitely. And you don't need a lot of compute that you're starting. There are better ways of solving this problem. What is the better way? If you know, all you have to do is serve files. I repeat, if all you have to do is serve files, why not use the most popular use case of serving files? CDNs and object stores. If you ever go to YouTube and get an MP4 file, it is not coming from an EC2 machine. It is coming from what's called a content delivery network. If a file as big as a video is being served via a CDN, there's probably a good reason for it, right? The reason is, if this is the world map, and if you want a file from some other place, be it an index.html file or an MP4 video file, let's say you are here in India and you want an MP4 file from someplace else. If that MP4 file was hosted on an EC2 machine, this machine exists in one data center. Your MP4 file is here, or your index.html file exists over here. When you send a request, it will have to hop so much to eventually reach a server in US, and then your response will come back from here. If a friend of yours is visiting the same website, they will also go to the same EC2 server, get back the response. Where does a content delivery network come into the picture? The name itself says, use me for content delivery. It's a content delivery network. It is a network of machines, which means there are thousands of machines, or what are called POPs, points of presence, that are present all around the world. And whenever you are trying to find, let's say, a file on an EC2 machine also, if you are going through a CDN, I repeat, if you are going to, let's say, cdn.youtube.com, then you will first hit your closest POP, your closest point of presence. This is nothing but a machine. And this machine will grab your contents from this EC2 machine. I repeat, this machine, this point of presence, will grab your contents and cache them I repeat, it will cache your contents so that if any other person in the same region asks for it, they get it directly from here. Can you see the benefit of a content delivery network? Even if your source, I repeat, even if your source is an EC2 machine, if you are going to your EC2 machine through a CDN, the CDN will begin to cache your files for some time. Of course, it won't infinitely cache it. But let's say there's a cricket match going on. In that case, isn't it nice? All the people in Punjab are getting their data directly from this cached point of presence rather than everyone hitting this server in the US. That is what CDNs stand for. In the end, whenever you're creating a CDN, you just have to give it a source URL. Okay, this EC2 server URL is my source URL, or this object store is my source URL. Now, what is an object store? We'll be coming to very soon. But irrespective of what your source is, you can put a CDN in front of it, and then every request that's going out will start to get cached in various points of presence based on who is asking for it. If there are a bunch of people in, Sydney asking for it, then again, this request won't directly go here. This request will first hit a POP that's in Sydney. That POP will very first time, for the very first user, of course, it will have to make this very long journey. But for all the second user, third user, fourth user, that file is present over here. Everyone can get that file from here. The file gets cached close to you. So in our React application, what do we want? Number one, clearly we should use a CDN. If in the end the same file is being served to everyone, if everyone is getting the same index.html file, why not serve it through a CDN? But the second thing is, where should you store your file? Should you store it on an EC2 machine, or should you store it on an object store? And there is no right or wrong answer here. Well, there is a right answer. Object store, as the name suggests, is a better place to store it. It is a store for big objects. What are big objects? Files, right? Index.html file, MP4 file, JPEG file. All these should not be stored in an EC2 machine. They should just be stored in a place whose sole purpose is storage. An EC2 machine has a file system. Sure, you can store files there. It has a network also. It lets you, run processes also. It has 10 different things it can do. Versus an object store can only store objects. So where should you store your files? In an object store. Harkirat, what are popular CDNs? CloudFront is the CDN that AWS provides you. Then Cloudflare also has an offering for a CDN. It's very hard for you to get in, though. You need to be a company. You don't see it in your dashboard, I think. But if you're a moderately sized company, you can use the Cloudflare CDN as well. GCP has one as well. These are popular CDNs. And what are popular object stores? S3 is the popular object store for AWS. And R2 is the object store for Cloudflare. So on and so forth. All cloud providers will give you this combination. When should you use this combination? You should use this combination if you are, number one, serving videos. If you are something like YouTube, you don't want to store these videos on an EC2 machine, store them on an object store, serve via CDN. If you're storing, JPEGs, if you're a website like Instagram, don't serve your images through an EC2 machine, serve via CDN. And lastly, even if you have a website which is static, it's a big word here called static. If it is a static website, what does static website mean, Harkirat? It means it doesn't have server-side rendering. If every user gets the same set of files from the server, then you can use it. When can you not use it? When you use NextJS, when you use something called server-side rendering. If every user gets a different content of index.html, Harkirat, how? We'll see when we reach NextJS. But if every user gets different contents, then you can't really cache it, right? If I cache my content on the CDN, my friend cannot get the same content. His content will be different. He will see a different index.html. And hence you can't use this combination there. The CDN plus, object store combination, but you can use it in case you're serving, files that are same for everyone. If you're watching a cricket match, everyone is seeing the same MP4, everyone is seeing the same set of chunks of videos. And hence there you can see it. On Instagram, everyone's seeing the same photo. It's not a user specific response. there you can use this. What CDN will we be using? We can use any, if I'm being honest. S3 plus Cloud Front is, as I said, the one for AWS. We will most probably be doing Bunny. Bunny is a new startup that's slightly cheaper than AWS. Doesn't mean it's better, it's just cheaper. Usually, as your company scales, and if you are really dependent on, a CDN pricing affects you, then you find a bunch of local vendors, smaller companies, negotiate prices. But if you do not have the option of negotiating prices, Bunny is a decent one. If your website is being visited a lot, CDN prices aren't very high. If all that people are getting are HTML files, they get high when people are getting videos. But if they're simply serving an HTML file, you would not worry about pricing. Doesn't matter if you deploy it on AWS or if you deploy it on Bunny. It's also just easier to deploy it on Bunny, which is why I'm going to show that in the next section. We're going to, number 1, sign up on Bunny. Number 2, create an object store. Number 3, create a CDN. And number 4, connect the CDN to our object store. Lastly, we'll connect our domain to the CDN. Let's go over all of these 5 steps one by one. All right, as I said, we can use any object store plus CDN combination. You can use S3 as your object store, Bunny as your CDN, Bunny as your object store, CloudFront as your CDN, doesn't really matter. But you optimize for prices eventually. If you have a company where CDN pricing becomes important, which, as I said, won't happen if you're hosting just a website, will happen if you have an Instagram-like use case where you're serving a lot of images. In that case, you optimize for price, and this is where you choose smaller vendors who have competitive pricing compared to bigger players. Bunny is one such player. We'll log into the dashboard. I think you have to put in your credit card here as well. Maybe not actually. They give like $5 of credit or something like that. This has been my primary CDN whenever videos don't work at the 100x devs cohort. Whenever there's a video that doesn't work for a user, we proxy it through this CDN. So that is why you will see, there are some small upticks here. Ignore this big tick, but like all these small upticks happen because sometimes people are not able to visit the video directly, and we proxy them through this CDN that we have. If you look at my current set of CDNs, I proxy a few requests to apexrecordings.livelearn.in, apextranscodedvideos.livelearn.in. This is our primary video provider, but in case they fail, I have created a CDN on top of them. So I route requests through my CDN because sometimes it happens this specific URL where the MP4 file is hosted is not accessible to specifically users in a college. So what is the other use case of using a CDN? Even if you have some other provider that is serving videos, you can put a CDN on top of them. In case some users are not able to directly hit this URL, they can hit your URL and their request can get proxied over here. For us though, we will create a fresh object store, a fresh CDN, and serve our website from it. Step 1, creating an object store. Go to storage over here and create a new storage zone. The same thing is called buckets in AWS. So if you go to S3, you can create a fresh bucket over here. Here you create an object, a storage zone. Name it anything. I'm going to name it 100x devs landing page. Storage zone doesn't really matter. You can add replication for better resiliency. So if I have 2 of them, for example, Singapore probably is a better place for me to put it because most users will be in India, and Singapore is closest to India amongst all of these regions. You can have multiple. If you don't want replication, you can have a single source of truth of your objects. The more replication you add, the more money of course you have to pay. Let's click on add storage zone, and you see a very Google Drive like interface. You can simply upload files here. That's all that an object store is. It's very similar to Google Drive. You put your objects over here. What object do we need to put? Do we understand React well by now? Do we understand React spits out HTML, CSS, JavaScript files? Those files are exactly what we need to put here. Locally, I have my source code over here. I've run npm run build over here in the past. And whenever I run npm run build, it spits out a dist folder which has all of the files that I finally need to serve. So what do I need to do? I need to take all of these files, the index.html file, the CSS and the JavaScript file, and all of my photos, and put them in my object store. I can open dist and I can just drag all the files that exist over here over to Bunny. And as you can see, very Google Drive like interface, it uploads all of my files to their servers. So much easier than creating an EC2 machine and then cloning some code over there and then running npm run build over there. Simply put all of your files in an object store. There is also a folder that I need to put. So I can click on upload folder and select the assets folder. I've added all of these files. To upload this folder, I select the folder, click on upload. And now I have all of my files as well as the assets folder. My object store is done. What's the second thing I need to create? I need to create a CDN, a content delivery network, where if a request comes to the CDN, I repeat, this part is done. We have created an object store, which has, my index.html file. What do I want next? I want a URL, something like, cdn.100xdevs.com, or, much better, something like react-3.100xdevs.com, where if a request comes here, it gets routed to this object store and, picks the index.html file, returns it to the user. How can I create that? There is a CDN section over here. I have created a pull zone. I need to create a CDN. Pull zone name going to be, let's say, this is where you want your application to be hosted. This is this default URL that Bunny provides you. Let's say I'm going to select something like 100xdevs website .b-cdn.net. I can of course customize this to my own URL. This is a very popular CDN if you ever have inspected websites that have videos. I'm not going to name which one.
Yeah, boy.
Origin type, as I said, this request can be forwarded to an object store. It can also be forwarded to a different URL. For our use case right now, we want it to be forwarded to a storage zone, which is why I'm going to select the 100xdevs landing page storage zone, the thing that we had just created. Scroll down a bit. Standard tier is fine. Where all do you want replication? If you want your Middle East users to suffer, because the pricing there of the CDN is really high. So what you can do is कि हमें तो वहाँ चाहिए नहीं भाई. If anyone from this region wants a request, their request will have to unfortunately come to Europe. You can remove all of these extra zones that are expensive. Why are they expensive? Because data centers in Middle East might be expensive, which is why the CDN there is expensive. Bunny also has to pay money to a data center, which is why if you feel this is too expensive, you can just select the cheapest one. Yeah, this is the cheapest one. But what is the problem here? If you just select the cheapest one, then all the requests will only go to South America in this case. Even Indian people will be going to South America. So, it will become further from them. If you want Europe people get their data from a Europe point of presence, then you can select the Europe region here, but you will have to pay $0.1 per GB of consumption versus if you select South America, you'll have to pay even more. This is 0.045. Sorry, the cheapest one are these two only. North America and Europe are the cheapest ones. So you probably want to select just these two. But if you have a lot of users in South America, then you'll, willingly pay itna ki chalo koi nahi yaar, we have users over there. And hence, it is fine if we have to pay a little bit more. At least they get better speeds. Add pull zone. And now my application is hosted. 100xdevs website .b-cdn.net is pointing to my storage zone. Any request that comes here will go to the index.html file over here. If I go to this URL, what do I see? I see my index.html. I see my website is hosted now on a content delivery network. There is no npm run devs. There is no serve running on a server. It is not hidden from me, the logic. I have created a storage zone. I have put my files inside this storage zone. If my website ever updates, if I have, more things in my landing page, I will just update the files over here. I will clear my cache and the CDN will now start to serve my new website. So if as your website updates, as more developers, deploy applications, you should be updating this storage. You should, delete all the files over here, add new files over here, and they'll automatically begin to get served from this CDN that you just created. How can I add a custom URL here, Harkirat? It's fairly straightforward. You'll see some as you can see, add a custom domain. Let's add react-3.100xdevs.com. It tells me, please add a CNAME record to react3.100xdevs.com. Let me go to domains.100xdevs.com, domains.google.com. Select 100xdevs. Click on DNS. Click on manage custom records and add another record here, which is of type CNAME react-3 and points to this CDN URL. If I save this and wait for a few seconds/minutes, react3.100xdevs.com should point to the website. Now it is not secure right now, but Bunny will install a certificate soon enough. It takes some time. As you can see, verify and activate SSL. Let me click on it. As soon as I do that, it will install a certificate for me as well. I don't have to use something like certbot to install it. Bunny will handle certificate management for me as well. Let's wait for a few more seconds for this to happen. That was quick. SSL certificate hosted. If I now refresh and go to https react3.100xdevs.com, I see my website hosted on react-3.100xdevs.com through a CDN, the best way to host a React application. We're done with the React section. Let's move on to more interesting use cases. This is actually a very simple thing to deploy and usually very cheap. Usually something you never have to worry about to scale. This will scale infinitely. Of course, not infinitely. Infinitely is a bad word. If you have a cricket match, then of course you will end up choking CDNs also. But usually CDNs are able to handle decent amount of traffic, especially if you are serving index.html files, JavaScript files. If you are serving video, that too during a cricket match, of course you will begin to choke data centers, and at some point you'll run out of, your Bunny will not be able to handle all of your traffic, so you'll move to another CDN. You'll have multiple, CDN providers during a cricket match. But if you're deploying a website, you should be fine. If you have 1 million users, you're good. More than 1 million users, that's fine. 10 million users should be fine. Since there is so much caching, you don't have to worry too much about scaling. Bunny has to, but even Bunny doesn't have to. Creating a CDN is actually a very simple thing, and it's a solved problem. What is not a solved problem is scaling backends. That is what's slightly harder. So let's understand that in the next section. All right, next up, we need to start deploying backend applications. Backend applications are very different from a static frontend like we've seen until now. They cannot be scaled via a CDN. I repeat, you can't really scale a backend application via a CDN. Can you guess why? Because if this is your EC2 machine, and if you put this in front of a CDN, then multiple users will get the same cached data. However, if this is user 1, this is user 2, this is user 3, and this is user 4. If they're getting back, let's say their Instagram feed, everyone will have a unique Instagram feed. If I send a request to a backend server, okay, hey, give me my latest 10 posts, then I should get back my latest 10 posts. The other person should get back different ones. If I use a CDN, then everyone will start to see my posts. You do not want that. And hence, unfortunately, when you have a backend, you can't scale it via a CDN. Every request needs to go directly to the source. If this is U1, this is U2, this is U3, all of them will be sending the request directly to an EC2 server. You can still have edge servers. You can still have multiple EC2 servers in various regions. And people can send a request to their closest EC2 server, but you cannot cache data at all. You cannot use a content delivery network. We're not serving content when you're serving a backend application, right? You're serving JSON data, XML, things like these. And hence you can't use a CDN. Let's first convert our Express application into a NextJS application. Let's add some backend in there, and then we will proceed to start to deploy it. Step 1, I'm going to create a new folder called Next Frontend. Database is a different question. We're avoiding that complexity, simply logging it, introducing a backend endpoint. Fuck. All right. Not much happened since I forgot to change the view. I just created a fresh Next.js application. the top level component of which the app/page.tsx, the very first page that you hit when you hit the landing page, looks very similar to our React application. We have a navbar, hero component, new courses and existing courses. If I run the npm, the Next.js application locally, you'll see it looks the same as well. But Next.js applications let you do something called server-side rendering. This specific page doesn't really need to server-side render. It can be what's called statically generated, but without going too deep into the jargon. And in fact, to make things slightly easier, what I've done is, anytime you click on the pre-register button, put your email here and click on, let's say, the submit button, I am hitting a backend now. I repeat, I am hitting a backend. I'm sending a request to the Next.js frontend /API/pre-register. Next.js lets you create backend routes as well. To create a route at /API/pre-register, you can create a folder in your Next.js project, API/pre-register, and create a route.ts file here. If you look at this file, I export a function called post, which simply gets the body that the user is sending, logs it on the screen, and returns a done to the user. Ideally, this should store this data in a database, but to avoid that complexity, I am simply logging this, and eventually from the logs, I can pull out who all have, subscribed to the cohort and send them out a notification. This is a backend endpoint. Now this is no longer a pure front-end application. Now this cannot be deployed the way we have deployed it until now. Every user is sending a different, request. This request has a different body. Every backend request needs to reach. I have trauma from going to this whiteboard, but I'll go again. If this is the backend and this is the CDN, if person 1 is sending their email, it needs to reach the backend. If person 2 is sending their email, it needs to reach the backend. I cannot have a CDN in the middle. Every request, at least the backend request, needs to go directly to the source, which means I cannot scale this via a CDN. The same is true for a Rust application, Golang application, doesn't matter what you're building. And hence, now we have to go to the new way of deploying our applications. We have to basically deploy it on virtual machines. But how can we scale it? How can we, without a CDN, ensure if traffic goes up, our number of servers increase, traffic goes down, number of servers decrease? To recap the project, we have a Next.js application. I can run npm run dev and see a landing page. But along with the landing page, I now have a pre-register button where someone can put in their email. When they do, this request, this email reaches back to my backend, and my backend logs their email and the course that they want to buy on the screen. Eventually, we will see how we can convert this log into a database and store it somewhere better. Let's get into the first way of deploying a Next.js application. All right, to kick things off, you can still deploy this Next.js application on Vercel. In fact, the place where Vercel shines is actually Next.js. Vercel owns Next.js. But again, it's very expensive. If you deploy an application here that's actually being used, and the steps are exactly the same, just import your repository and you're good to go. It'll automatically deploy it. The problem is it'll get very expensive. I'm not doing those steps over here. This section is about cheaper serverless alternatives. Netlify and Vercel, even though they do directly connect to your GitHub, so they do give you some benefits out of the box, they get very expensive very quickly. Cloudflare Pages is an alternate where you don't get direct Git integration. You might have to write, the GitHub pipelines yourself, but they let you, the price is much cheaper. And I haven't looked at the prices, both the places. In fact, the prices are fairly complicated for Vercel, and I'm sure for these guys as well. I've just run real world experiments. I first deployed an application on Vercel and had a bill of $720 in like a week, moved it to Netlify, $300 in a week, and finally moved it Cloudflare. Worked free for a really long time. And hence, this is a cheaper alternate in case you want to deploy an application that's not just front-end, both front-end and back-end. These guys also have a serverless. If you have a pure back-end application, they have a serverless offering called Workers. That's also number one fast. Number two, fairly cheap. If you want to read about it, they have very nice blog posts around how they've built workers and how are the workers over here, how are they different from Lambda or other serverless offerings. Fairly good reads in case you feel like reading them. I am going to proceed. If you do want to read them, they're here at 𝗟𝗶/what I'm learning. This last blog post is what I'm talking about, how they've built their serverless runtimes compared to other cloud providers. Let's get into how can we deploy our NextJS app. Step one is signing up to Cloudflare. So if I go to cloudflare.com, I already have an account. I've put my card in there, but I think this will work even if you don't put in your card. As long as you're able to log in, you should be able to see a section on the left called workers and pages. This is where we'll be deploying our very first page today. Workers is pure backend, pages are both frontend and backend. How do you initialize a page locally? You can add it to your existing Next.js application as well. Or let's just create a fresh Next.js application and then slowly update the files over there to deploy our final project. This is the first command to run. npm create Cloudflare @latest. The name of your project, let me name it Next 100x Devs app, and the framework that we're using Next.js. It'll ask me about the defaults. I just selected the defaults last time as well. I'm selecting the defaults this time as well. It asks me, do you want to deploy your application? And in my case, the answer is yes. Let's just deploy it. It'll deploy a very basic Next.js application for me. If you've not ever logged into the Cloudflare CLI, it'll ask you to sign up. After you've signed up, it'll be able to deploy the application for you. All right, the application is deployed. If I go to next-100xdevs-app.pages.dev, I see the default Next.js application deployed over there. I want to now replace this with my own application, which means I want to replace the source code in this next-100xdevs app to have the same source code as my landing page and the backend that logs the user's request. Let's open this in Visual Studio Code. I've added this Cloudflare adapter Next.js project right next to my original Next.js project. Let me quickly update all the files in the app folder to be the files in our original app folder. The page.tsx should render something like this. We should have all the components. We should have our own backend API route. So I'm just going to copy all of these files in the app folder. Go to the Cloudflare backend. Delete all of these files. And then copy the files from the other place here. That should be enough, right? Let's see what happens if I create a new terminal and run npm run dev over here. Seems like it worked. The images are messed up. Can you guess why? Because I forgot to copy the images from the original project. If I go to the original project right here, public/all of these files, I can copy these files, go to public folder in the new Cloudflare project and paste all the files over here. Now if I refresh, I see the images here as well. At least locally, the Cloudflare adapter Next.js application seems to be working. When I run npm run dev, it seems to be working. Will it work when I run npm run build though? Let's see. Next.js can be a little more strict, or you can make it a little more strict compared to React. So it might happen that whatever was compiling in React no longer compiles in Next.js. And that's exactly what happens here. It tells us there is an error in existing courses. You should pass a key over here. Let me quickly do that. And same thing in another file. Or just a single file. Very good. There we go. I assume there were two files that had a for loop. Wait for it. Now seems like that's enough. At least locally npm run build is working. What does npm run build do in a Next.js project? It creates this .next folder. How do you start a Next.js project in production mode locally? You start it locally by running npm run start. After you've run npm run build, I already ran npm run build, it worked. After I ran npm run start, seems like it's working fine in production mode. Let's try to deploy it. Since we've used the Cloudflare bootstrap, I can run npm run deploy. This deploy script over here would run the code to deploy my application to my page. What does deploy do? If I go to package.json, deploy runs npm run pages : build and Wrangler pages deploy. This deploys my application over to Cloudflare. But what error do we get? We get an error that says that on /API/pre-register, you should add an export that lets it run on the edge. Make sure all your non-static routes export the following edge runtime route segment config. The backend is indeed non-static. It is different for everyone. So let me go to app/API/pre-register/route.ts and export this over here. Let's try to deploy that one more time. Seems like that worked. If I open this page, I see my application is deployed on the internet on Cloudflare, a cheaper alternate to Netlify and Vercel. Can I attach my domain name over here? I'm sure you can. Let's go to workers and pages in the Cloudflare dashboard. Let's look at our recent page that we deployed. Next 100x devs app. Let's go to settings, custom domains, set up a custom domain. Let's call it next-1.100xdevs.com. This is the CNAME entry that I need to add. Let's go to domains.google.com. Next-1 needs to point to next-100xdevs-app.pages.dev. I've added the entry in my DNS provider. Let's go back here and check the DNS record. Oh, oopsie daisy. Seems like this will take some time. Okay, we're back after 10 minutes. The website has indeed deployed on next-1.100xdevs.com. If you look at it, we also have an SSL certificate attached. We're good to go. That's how you deploy our application on Cloudflare pages, a slightly cheap alternate to Netlify. But how can you deploy it on your own machine? What if you want to deploy it to your own VM? Very similar to how we deployed a React application in the last section. Let's understand that next. All right, I'm assuming this is straightforward, guys. We've already done this once. Step 1 is going to be creating an EC2 machine. Let me name this one Next App and select maybe Ubuntu as the operating system. Maybe a small or a medium machine, doesn't really matter. No key pair is fine. Allow traffic from HTTP at the very least. 8 GB is fine. Launch instance. Proceed without a key pair. While this is happening, what is the other thing I have to do? I should deploy my application on the internet. I'm going to remove the Cloudflare application that we had here. I will just have the next front-end application that we built a while back. Does this application build correctly locally? Let's see. I have to make the same change here as well. I have to add a key to this specific render course.title. Let's try to run this one more time. Seems like it worked. Next step is creating a GitHub repository. Make sure it is public and push your code to this specific GitHub repository. Make sure that the code appears here on GitHub, and now you can go to your AWS machine. On this next app instance that we had created, it's still initializing, so let's wait for a few more seconds. There you go. Now that the instance is up, let's try to connect to it. Connect using the EC2 instance connect, and we should have a browser window that's connected to our EC2 server. Do you remember what the next step was? It was installing Node.js over here using NVM. So DigitalOcean. Let's open the blog post on the right, machine on the left. We're going to again use NVM to install it. NVM install node. Let's clone the repository next. Let's go to the repository. Let's run npm install. Let's run npm run dev. And as you can see, it says the application is running on localhost :3000. Let's try to run it in production mode, npm run build. Followed by npm run start. And this also says the application is running on localhost :3000. Can we quickly open port 3000 on our machine? What are the steps to do it? Go to the machine, click on the security group, select the security group for this specific instance, and add an inbound rule. We want to allow custom TCP traffic on port 3000 from anywhere. If I click on save rules, now if I go to my EC2 machine's IP :3000, you will notice my NextJS application is deployed on my instance. How can I connect it to my domain? I think you know by now. If I go to domains.google.com, select my domain, go to DNS, click on manage custom record, create a new record for, let's say, next-2.100xdevs.com, and a record that points to the IP of this server. If I click on save and wait for 30 seconds to an hour based on how lucky you are, next-2.100xdevs.com :3000 seems to be working. What's the ugly thing over here? I have a :3000 here. I should be starting this on either port 80 or port 443. Harkirat, what is port 443? It's the port used for HTTPS. Second thing is this isn't secure. How can you make it secure? Again, I've shared the steps a little bit a while back. Happy to do it here as well. You can do one of many things here. You can either use a reverse proxy plus certbot for certificate generation. The reverse proxy will make sure you don't have to do the ugly bit of adding a :3000 here. Certbot will make sure it has deployed a certificate for you. The other thing you can do is, start the next app directly on port 443 or 80. This is something you shouldn't do ideally. You should just go through a reverse proxy, something like Nginx that's running on port 443 that forwards the request to your process. The other way you can do it is this. Either way, here also you will need a certificate which you can either get from certbot or you can buy it off from various providers that exist on the internet. I will leave this to you as an assignment. Again, I'm leaving this as an assignment. The only assignment, well, there are a few assignments you'll see towards the end of the video as well. For example, CI/CD pipelines. Right now, the code isn't deploying directly from my GitHub over to my EC2 machine or over to my Cloudflare workers. So that's also a good assignment to do. Another good thing to figure out here is how can you add an SSL certificate over here? How can you create SSL certificates for free? How can you attach them to a process that's running on your, EC2 machine? Cool. That's done with the second way to deploy a NextJS application. Next up, self-hosted on a home lab. Something you probably shouldn't do. But if you feel like you want to get a little adventurous, let's discuss how can you start the NextJS application locally and expose it to the world using Cloudflare tunnels. All right, what if you want to get adventurous? If you want to expose your local Mac machine on the internet. I repeat, you want to make sure if someone comes to next-3.100xdevs.com, this request gets routed to literally my local Mac machine over here. The NextJS server npm run start is running on my Mac machine, is the machine that is serving all the traffic. Now, what are the downsides to this? Your Mac machine is unreliable. You're exposing it to the world. Your internet might go down, your light might go away. We live in India, so you shouldn't do this. Applications should ideally be hosted in a data center like AWS. But if you want to get adventurous one day, and there are use cases where this makes sense also. For example, if you want to deploy, if you have a bunch of CCTV cameras at your house and you're taking that footage, putting in your local machine or a home lab that you have, you might want to expose that over cctv dot whatever your website is .com, and of course want to protect it with some passwords. But a lot of times you store some data in your home lab. A lot of people have very sophisticated home labs, in which case it makes sense for you to expose it to the internet. If you want to do that, if you have a legitimate use case, you can use what are called tunnels. Cloudflare lets you create tunnels. You can create them yourself as well. The idea is any request that's coming to a public facing IP or a public facing URL, this IP points to a server on the internet, a Cloudflare server, an EC2 server, but that just tunnels the request to your local machine. A local machine cannot expose processes on the internet. You do not have what's called a public IP. There are ways of doing this. You can punch through your router and expose things on certain ports. But if you want SSL traffic on port 443, it's very hard for you to punch through your router and get a public IP. You will have to go through a cloud provider only like AWS, who has a bunch of public IPs. Just ask them, okay, hey, give me a machine, and whatever is the public IP of this machine, the request comes here, you tunnel it to your local Mac machine. And every request that's coming it's almost equivalent to that request coming on your Mac machine. The response also gets routed back to the end user. Question is, how can you create this tunnel? And the answer is, as I said, you can self-host this as well, or Cloudflare lets you create what are called these tunnels. The way it works, firstly, how do you reach this page? If you go to the Cloudflare dashboard, click on Zero Trust over here, then select networks/tunnels. It gives you the option to create a tunnel. What does it say? Step 1, you have to install and authenticate Cloudflare D. They require you to run a daemon, a process on the machine that is finally getting tunneled to. Whenever you start this process is when Cloudflare knows, this is the machine I now need to talk to and tunnel all the traffic to. So what is step 1? Installing a daemon on a machine. A daemon basically means a process. And this process has, decent chunk of powers. It can handle incoming requests and, hit a specific port on your machine. So be very careful as to, before doing this or even, doing this on or using Cloudflare, because then Cloudflare has access to your machine. It has a process running on your machine. Pick and choose if you want to do that or not. I personally don't want to do that. For this experiment, I will be routing all the requests to our EC2 machine. I repeat, for today's experiment, at least for me, the EC2 machine that we created in the last slide is where I'll be tunneling all the Cloudflare traffic. I will not be sending, I should ideally be sending it to my Mac machine to, for it to really justify this section, which is hosting it on your own Mac machine. I can do that. I can host my NextJS application here. I can also tunnel the traffic here, but I'm not going to do that for security purposes. I'm just going to tunnel the traffic over to the EC2 machine we created in the last slide. Steps remain the same. You can always, if you really want, run this locally and run the Cloudflare daemon locally, and in that case, the request will get routed to you. Click on add a tunnel, select how you want to do it. We're just going to go with Cloudflare daemon. Let's name it next-3, save a tunnel. And after this, it gives you steps based on the operating system you are on. We're on Debian. Since we're running it on an Ubuntu machine, I'm going to copy the steps and paste it on the Ubuntu machine that we started in the last section. There we go. Linux services for Cloudflare deinstalled successfully. If I go here, you can see it has a connector connected. If I click on next, it asks me what URL, I repeat, what URL Harkirat, for example, next-3.100xdevs.com, what URL should point to what processes over here. What is the process running here? It's running on localhost :3000. And hence, what do I want? This is my base URL. This is the process URL. The base URL is next-3 dot. Now I have a different domain on Cloudflare. Cloudflare also lets you do domain management. And here, if you want to use something, let's see if I can use my 100xdevs.com cohort. Domain. Route traffic zone is not associated with the current account. You need to have a domain that is present in Cloudflare. I repeat, you can move domains to Cloudflare just like I have a domain in Google Domains called 100xdevs.com. I have another one called 10kdevs.com, one step ahead of 100x, which is in Cloudflare, and hence I can use it right here. next3.10kdevs.com/nopath is going to point to http://localhost:3000. Any request that comes to next3.10kdevs.com gets routed to the process running on port 3000 on this machine. Let me also start the process here. Save tunnel. Let's open this URL in a new tab. And as you can see, on next-3.10kdevs.com, the application is now hosted. If I stop the process, the NextJS process on my AWS machine, it says bad gateway. It cannot tunnel to my EC2 machine. But if I restart the NextJS process here, the website is up again. Now, if this EC2 machine was my local Mac machine, I could have run the daemon there as well. And in that case, the request would have been routed to my Mac machine. Pick and choose if you want to do this. Next up, we'll understand auto-scaled servers. If you definitely cannot do something fancy like home labs, you can do serverless. It might get costly. We can move to Cloudflare pages. It might not be costly. Only time will tell. What if you want to self-host? Harkirat, I just self-hosted here on EC2 machine. Yes. What if you want to self-host and auto-scale up and down? That is what we will discuss in the next section. All right, the biggest problem we've had until now is that we've used two kinds of systems. Number one, self-hosted. And number two, when we've used either a platform as a service or we've used serverless. What's the problem in both of these architectures? Here the problem is it does not scale. We have deployed it on a single machine. If 1,000,000 users are hitting your servers will begin to choke. You should not be reliable on an architecture like this. You should ideally auto scale your servers. On the other side though, if you're using a Paas, it will auto scale very well. Scaling is not a problem over here because they handle it for you. What is the downside here? It's the pricing. It can get really expensive and pricing can be unpredictable, especially if you're under attack, if you have a lot of people visiting your website generally. There are no cap to how much bill you might have to pay. Of course, you can have budget limits, but generally, it can be highly unpredictable how much money you have to pay. There is also usually some extra margin / premium you have to pay because they're handling scaling up and down for you. Since they are handling traffics for you, since they're handling spikes, you have to pay them a little bit extra compared to if you were self-hosting. So the question is, how can you self-host yet have some level of auto scaling? How can you handle traffic spikes even when you're not using a platform as a service? Now the better way to do this is use some sort of container orchestration engine like Kubernetes. But before we reach there, cloud providers, or I should say big cloud providers, provide you constructs to auto scale. In AWS, this is called an auto scaling group, which as the name suggests, lets you scale your servers up and down. Until now, we created a single server. But what if we could, define some limits? If the CPU percentage is greater than 50%, then please increase the number of servers. And if it goes below 10%, then please decrease the number of servers. Have a min, have a max. And the number of servers that you have up purely depend on either your CPU usage or let's say the number of requests you're receiving, so on and so forth. Big cloud providers had this concept of scaling up machines even before, container orchestration engines came into the picture. Let's try to build one of these. Let's try to use AWS to create an auto scaling group. But generally, if you want to self-host yet have auto scaling, defer to some container orchestration engine like Kubernetes. This is good. It has some downsides. The time it takes to boot up a server is really high. So, if you have a traffic spike, then, you might not be able to handle it for the first 5 minutes or so. It's not too bad if I'm being honest. If you're a complete beginner, it's actually, one of the easiest way to get a scalable app off the ground. We are going to be using auto scaling groups, but we won't directly use them. You can take two routes here basically. You can either build an auto scaling group from scratch. Now this would involve number one, you starting an instance. Number two, creating an image out of it. Number three, creating a launch template. Number four, defining some sort of a start script in your launch template. And lastly, creating an auto scaling group with a load balancer on top. You can either do these 5 steps, or thankfully, AWS provides you something called as Elastic Beanstalk, which under the hood does all of these 5 things for you. It just hides all the complexity. All you have to give it is a zip file of your Node.js code, Golang code, in our case, NextJS application. And it will do all of these steps for us. Under the hood, it will still create an auto scaling group for us. It will create a load balancer, but you won't have to handle all of that complexity. You can still see it in your AWS dashboard that you have an auto scaling group, but it's been auto created for you. We're taking this route, but if you're in the cohort, you've probably seen this in the past. Generally also good to know how can you create these from scratch. If you want to hide this complexity, EBS is the way to go. Let's create an Elastic Beanstalk application, deploy our NextJS application over there. All right, steps are fairly straightforward. Search for Elastic Beanstalk. Click on Create Environment. we're going to be creating an internet facing application, and hence we have to select a web server environment. If we were creating just a worker that does something offline, you can select a worker environment. This would have a load balancer. I would assume this just does not have a load balancer attached to your cluster. Give it a name, next 3 or 4, I guess. Next 4. Let's leave it empty for an auto-generated value. The domain. The application code. Let's select sample application for now. This will deploy a sample Node.js application as long as the platform that you've selected here is Node.js. I repeat, the platform that we are deploying, the application that we're deploying is a Node application. Harkirat, it's a Next application. Yes, it does use NPM, right? So as long as you have Node installed on your machine, you should be fine. Select Node.js over here. If you were deploying a Golang application, then you would select Go. Sample application basically means it's going to deploy a sample Node.js application for us. Presets single instance is fine. Application name, let's give it next-4. Next. Service access. Now here is where you have to create what's called an IAM role. I already have one, which I can select. But for you, you can go to your IAM dashboard, create a fresh role, give it all of these permissions that have been mentioned here, and then you can select that specific role before proceeding to the next section. Next up, networking. You can select a VPC. Default VPC is fine. Select a few availability zones. The shape of your server, I think whatever is here by default should be fine. Security groups, in case you need some extra access on them, you want to open some ports. We don't, so we'll just let it be. Auto scaling groups. Do we want a single instance or do we want a load balanced auto scaling group? We want a load balanced auto scaling group. What is the minimum that we want? Let's say 1 machine. What is the maximum that we want? Let's say 5 machines. On what basis do we want to scale up or down? I can't see it here. There you go. Scaling strategies. We'll eventually, get to this. This is based on network. We'll probably base it out on CPU utilization, so it's easy to test. Instance types. Select small at the very least here, else you'll see some issues because we'll be building our NextJS application on this server, and small is probably also not enough to build a NextJS application. It'll just stay stuck. So select maybe medium. Medium should be more than good enough, I think. Let's see. C5.large is also fine. Next. Leave this as such. Review, submit, and let's wait for this environment to finish deploying. This now is under the hood is creating an auto scaling group for us. Right, one more step that you have to do is create what's called an instance profile. We skipped this, which is why the environment did not create for me for the first time. I already had an instance profile that I can reuse, this EKS instance profile that's created for me, or you can create a fresh one. I just can't find a way to create an instance profile using the GUI. And so I've found one way to, create it using the CLI. If you have the AWS CLI, and if it has access to your account, you can run AWS IAM create instance profile, give it a name, and that should create an instance profile that you can use while creating or while setting up the Elastic Beanstalk container. If you don't do this, your container will crash. If you look at it, I have, a few of these environments that are terminated. These are automatically terminated. If you open one of these, you'll see the error that says environment must have an instance profile associated with it. So make sure you either create one, if you already have one, it has the right permissions and it's attached to your Elastic Beanstalk environment. If I open this next for env2, which is, the final one that I ended up creating, which does have an instance profile associated. Here, if you look at it, I see, a URL where if I go, some sort of an application is hosted. Now this is I would assume a Node.js application, maybe not, could be a different, stack as well. Either way, now I can deploy my own application in this, Elastic Beanstalk environment. Harkirat, what is this Elastic Beanstalk environment? As I said, it just creates a bunch of auto scaling groups under the hood. So if I go to EC2 and scroll down to auto scaling groups, ignore this one. This is my Kubernetes cluster. This is a fresh auto scaling group that got created for you. Could you have created one yourself? Could you have clicked this button and created one? Yes. What was the benefit of using Elastic Beanstalk? You pressed a few buttons, it created one for you. If you delete your Elastic Beanstalk environment, it will also delete this auto scaling group for you. What does the auto scaling group say? It says desired capacity is 1, minimum is 1, maximum is 1, which means it's not really an auto scaling group just yet. Let's see how you can convert this into an auto scaling group that actually goes up and down. You can either directly edit things here, since now you have an auto scaling group, or you can go to your environment, which this is our environment right now, configurations, and make a few changes over here. The second time when I started this, I sort of forgot to add a load balancer, an auto scaling group, which is why, even the instance types, as you can see, are micro and small, which is something we shouldn't have. So let's quickly edit this. Let's change the instance types to be, medium at the very least, or C4. Well, that's a little too big. T3 medium works. A T3 medium is great for our application. That will be the instance type. And yeah, let's save that. Let's also change the fact that it's an auto scaling group. Right now it just has a single instance. Let's change the min and the max, which, as I said, you can directly change in the auto scaling group as well. Come on, where is it? Updates, instance traffic and scaling should be here. Capacity, it says single instance, select load balanced, and change the min and the max. Let's say minimum 1 machine, maximum 3 machines. Let's save that. And now if you wait for a bit, you will see the maximum capacity will go up to 3 very soon. The desired capacity is the number of instances that are actually running for your application right now. What is our application? It's a dummy application right now. Harkirat, how can I deploy my NextJS application over here? Great question. Elastic Beanstalk lets you upload your code and then it automatically deploys it on the instances. So what do you have to do? You have to first, grab your code, convert it into a zip, and then just upload the zip over here. What does our code look like? It is exactly the same code that we had, only I've changed the start script a bit. I'm running npm install followed by npm run build followed by starting the final thing with whatever Elastic Beanstalk passes as the environment variable, this port variable. We're starting NextJS, the NextJS server on the same port. I repeat, whenever Elastic Beanstalk starts a specific server or a specific process, in this case it runs npm run start, it will pass in the port as the environment variable, the port on which it wants the application to run. I think by default it's 50-50, so I could also do something like this, but generally this port environment variable is where Elastic Beanstalk expects you to start your application, and hence whenever we're running next start, we're passing in this environment variable as the port to start it on. Why are we doing npm install and build here? No idea. I tried to basically deploy it without it, but either the archive is getting corrupted, it's just not, npm run start on the server was giving a bunch of errors, which is why when I removed the node modules on the server and re-added them and restarted, it worked. And hence I'm just going through all the steps of building it directly on the server rather than building it locally. Ideally you probably want to build it locally and only pass over the dist to the server. Once you've done this, you can zip, which means if this is all the contents of your folder. You can create an archive out of it. For example, I've created one over here. How can you do it? You can run this command at least on a Mac machine, zip-r archive name, whatever is the name of your zip file dot, or, if you want to not get this fancy, just select all the files that you want to compress, which is, the complete folder, right click on it, click on compress over here, and then it'll just create a zip for you. This is just a zip file that has all of our code. Now go back to, the Elastic Beanstalk dashboard, click on choose file, select your archive. I'll just select the latest one that we just created and click on deploy. And it says, it gives me an error. It's probably because I named it incorrectly. Let me do that one more time. Oh no, it is updating. Don't even worry. I think I clicked the button twice. The first time it worked, second time it gave an error. Elastic Beanstalk is updating your environment. To cancel this operation, click on whatever. Let's wait for it to upload our code to the server. Let's see if that does what it's supposed to do. Alrighty, that seems to have worked. It says environment update completed successfully. And if I go to the URL that was originally pointing to that dummy Node.js app, it now points to, our Next.js application. What did I do? I archived my code base over here. I created an archive.zip file from all of my code base, compressed it into a single, zip file, uploaded the zip file over here. And now whenever my code is deployed, Elastic Beanstalk understands that there is a start script over here. It runs this start script on the respective servers and, has a load balancer in front of all of my servers through which I'm trying to reach, my final instances that are running Next.js. Question is it auto scaling? Elastic Beanstalk in itself is nothing. It just creates an auto scaling group for you. Let's look at the auto scaling group and see the minimum capacity is 1. The maximum capacity is 3. The desired capacity, the current capacity is 1. If I go to instances, if I go to instance management, I see 1 instance is currently running. Whenever I'm sending a request here, it is actually eventually reaching this instance. If I connect to this instance as well, I repeat, if I connect to this instance, I can actually see my source code. This is the instance where, my Next.js application is actually running. Where does Elastic Beanstalk store my code? /var/app/current. If I go to cd/var/app/current, you'll see my Next.js code is here. If I do a cat package.json, you will see the updated start script is over here. This is the code residing on this machine right now that is handling all of my incoming requests, any request that goes over here. Question is, does it auto scale? What's the easiest way to know if it auto scales or not? Firstly, if I go to the auto scaling group, I can go to this place called automatic scaling and it shows me what all policies we have for scaling. Let's remove these policies are based on network, which means the number of incoming and outgoing requests. This is good, not requests, like the number of incoming outgoing bytes. This is good, but it will be very hard for us to test. I can't really bombard this with, a bunch of bytes. I actually can, but an easier way to do it is just, do it based on CPU usage. So let me change the automatic scaling policy, which again, you should probably change from this Elastic Beanstalk dashboard. I'm just changing it directly over here. Let me disable both of them and let me create a new dynamic scaling policy where in my auto scaling group. I'm saying I want to target a specific level of CPU. I want the average CPU utilization to, let's say, be only 20%, which means if it goes above 20%, we want to scale up. If it of course goes down a certain threshold, we want to scale down as well. But we want our average CPU utilization doesn't go above 50. Ideally, this number should be like 70 or 80. But just for testing purposes, just so that we can see the server fleet scaling up, I'm selecting a fairly small number so that if I send a bunch of requests here, the CPU usage hopefully spikes, the number of servers go up. What is my dynamic scaling policy that I'm adding? Here, if the value goes above 20%, if the average CPU usage goes above 20%, we should scale up the number of servers that we have. I've added this target tracking policy. The only thing that's left to do is increase the CPU usage on the machine. How can I do that? I can either try to hit this machine again and again, send a bunch of requests, or since I'm already in this specific machine, can I create an index.js file which simply runs an infinite loop? I repeat, if I create an index.js file which runs an infinite loop and start it, would this spike up the CPU usage of the server? It would. It's an artificial way to spike up the CPU usage. Ideally, you want to load test it slightly better. You want to send a bunch of requests here, and that should in turn spike up the CPU usage here, just for testing purposes, just so that we can see that our auto scaling policy is working correctly. Okay, the CPU utilization, if it goes above 20%, we indeed scale up. Just to test that, I've started an infinite loop on this server that should spike up the CPU. When it does, hopefully our auto scaling group auto scales up. This takes time. It doesn't happen immediately. What we can do is we can go to the instance and track the CPU usage here. So if you open the instance and click on monitoring, as you can see, there's a small spike right now. This spike should, probably reach a lot bigger unless I selected a very big machine. This should probably, go beyond 20% very soon. And if it does, then hopefully our servers scale up. Let's meet back in 5 minutes. All right. It's been like 3-4 minutes and the desired capacity automatically became 2. I repeat, the desired number of instances went up by 1, which basically what that does under the hood is starts another instance. In fact, it went up to 3 now. If I refresh, you'll see the desired capacity became 3 automatically. Of course, I artificially increased the CPU usage on a server, but I did not have to start any of the other 2 machines. This desired capacity went up to 3, which under the hood starts 2 more instances for us. And that is how you see 3 instances currently running. If you look at the activity section over here, it will tell you, okay, first the capacity went from 1 to 2. At this time, a monitor alarm, this specific ID, in a state alarm triggered the policy target policy, changing the desired capacity from 1 to 2. And then another one happened that increased the target capacity from 2 to 3. If I, of course, stop this infinitely running for loop, then eventually you will see these scale down to 1 as well. Which means similarly in the real world, if there were a bunch of requests coming and the CPU usage spiked up, or if you remember the other auto scaling policies that were here, which were based on, the number of bytes that are coming in and coming out. Based on that also, if there are a lot of requests that are coming in, a lot of bytes that are coming into the server, you can scale up. And if this number goes down, you can scale down as well. Cool. That is how you create an auto scaling group. You can create naked auto scaling groups as well. You don't have to go through Elastic Beanstalk. This is a very commonly used auto scaling construct in AWS. What do I mean by auto scaling construct? By construct, I basically mean, all you have to do is come here, click on edit. And let's say if I make the desired capacity 1, it'll automatically, kill the other 2 machines. It's the best way to create auto scaling, servers from first principles. If you don't know what containerization is, if you have a raw Node.js application running somewhere, yet you want to auto scale, then, this is the easiest way to do it. A lot of cloud providers don't even have this functionality. Most cloud providers do provide scaling up and down, but only when you're using Kubernetes. They don't allow node scaling, using constructs like an ASG does. I think GCP has one as well. Pretty sure. Striver only told me that he was working on, something related to that. AWS has an auto scaling group. DigitalOcean, if I'm not wrong, unless this has changed recently, up until 2 years ago at least, I don't think they had any such construct. If you had to auto scale up or down, you had to use a Kubernetes cluster. That was the only way to scale up and scale down instances in DigitalOcean. Cool. That's how you create an auto scaling group. What are we discussing next? We are first containerizing our application. That's what the next section is going to be. Then we will understand about container orchestration engines. We won't dive too deep into it, but I'll show you my ideal way to deploy applications today, which is deploying it on my Kubernetes cluster. If you remember, there are 2 auto scaling groups here, the one that we just created, and then there is one below it that looks like this, right? It's called EKS Linux prod. EKS stands for Elastic Kubernetes Service, I think so. And this is where, today I deploy most of my applications. This is where we'll be deploying the landing page as well. So let's understand how do you containerize our application, and then we'll understand various ways to deploy it. All right, in this section, we're going to containerize our application. Specifically, we'll be writing a Docker file for it. We'll deploy it on Docker Hub. If you have a backend, it's always a good idea to containerize it before deploying. You can run, raw Node.js files on a server, but for a bunch of reasons, decreasing the blast radius in case someone has access to your machine, restricting them to, just the Docker container, avoiding all the overhead that comes with, installing Node.js on an EC2 machine. One big thing that we have done again and again right now, when we were deploying on our own virtual machine, we first had to bring in NVM. After we brought in NVM, we had to install Node, and only then were we able to start our applications. Wouldn't it be nice if, irrespective of what kind of machine I'm running it in, could be a Mac machine, a Windows machine, or a Linux machine, I could run a single command. I could simply run docker run xyz, and this would start the NextJS server running on a specific port. That is what containers let you do. Container orchestration just makes it very easy for you to deploy these containers, left, right, and center. But before we get there, let's containerize the application. Let's write the Docker file for a NextJS application. If you know Docker, this is simple. If you don't know Docker, this is hard. I have a detailed, 2-part video on YouTube. Feel free to look at it if you don't know what Docker is at all. I'm going to create a Docker file in the root folder. That looks right. We start off with a base image that has node version 20 installed. Working directory is /app. We copy over all the packages. We run npm install. We copy over the rest of the code. We run npm run build. We expose port 3000. And finally, when the container starts, we run npm run start. What's the next step after you've created a Docker file? It's creating the Docker image. So docker build -t. I'm going to tag it with 100x devs /landing dot, and it says Docker isn't running on my computer. So let me turn on Docker. There we go. Let's build the image again. That seems to have worked. That means our Docker file is most probably right. Let's try to run the Docker image locally. Let's not deploy it anywhere right now. Let's just run it. Docker run -p 3000:3000 100x devs /landing. Why is it rebuilding it? Because I forgot to update the package.json. The package.json still has all of these steps. I should remove all of it. Package.json should only have next start, nothing else. Let's rebuild the Docker image. Let's try to run it. If I go to localhost :3000, I do see my application. So seems like my application is containerized correctly. What is my image called? It's called 100x devs /landing. Next up, I'm going to push this to Docker Hub. If you go to hub.docker.com, it lets you push your images. If you're pushing public images, it's free. Let me create a public image or public repository here called 100x devs /landing. And now I can simply do a docker push 100x devs /landing. Again, the command that I ran was docker push 100x devs /landing. This should push my image to Docker Hub, which I can then pull in various runtimes. This section will have 3 runtimes: a decentralized compute, Kubernetes, and if we get the time, Coolify. And all of these can, use this Docker image. The the point of using a Docker image, or the benefit of using a Docker image, let me explain that while this happens, is that if this is your GitHub where your source code is present, on every commit you can push a fresh image to Docker Hub, which has the latest code of the user and all the auxiliary dependencies, things like Node.js in our case, and then this image can be pulled by various places that can deploy your application. This can be pulled by Elastic Beanstalk. If you go to the Elastic Beanstalk dashboard, you'll see you can also deploy a Docker image or a Docker container over there. Amongst the various runtimes it supports, Docker is one of them. You can pull it to a Docker Swarm. A Docker Swarm is very similar to Kubernetes, only it did not get as much attention as Kubernetes did, but it's also a container orchestration engine. And lastly, you can pull it to Kubernetes as well. The other place that we're going to discuss is pulling it onto a decentralized compute platform, which basically means you're able to rent a machine from someone, by paying them some crypto. All of this is, just easier if everyone knows, we have to start Docker, and on this Docker runtime, I have to start this specific image. It's a clear format. A container is a clear format that everyone can run in their respective Docker runtimes. Versus if we had not containerized the application, the decentralized frontend would first have to install Node.js, understand this is a Node.js application, understand you have to run npm run start to actually start it. Versus, since we have shoved all of this in this Docker file, in the Docker file we have written, the final thing that needs to run is npm run start. Everyone can simply run docker run 100x dev/landing, the same thing that I ran. What did I run a few seconds ago? I ran docker run -p 3000:3000 100x devs/landing. Now anyone, including you, if you run this specific command, as long as you're on a Mac machine, you should be able to see the application running locally on your machine. If you're on a Linux machine, you will see some errors. Let me also publish a Linux version so that people who are using Linux and even our Kubernetes cluster, which does run Linux machines, can run this specific application. The way to do that, if you are on a Mac machine, just add --platform equal to Linux -AMD64, and let me tag this with something like Linux Alright, now that that's done, I'm pushing this Linux image as well, so that if you're on a Linux machine or our final Kubernetes cluster is going to be a bunch of Linux machines, they are able to run this specific image. Alright, if I go to hub.docker.com now, you will see 100x devs/landing has two variations, a latest version, or a version tagged with latest, a version tagged with Linux. This is the one that we'll be using in our final Kubernetes cluster. Let's understand what is Kubernetes very high level. How do you deploy a simple Docker container over there that needs to be exposed over the internet? All right, let me do a very quick Kubernetes 101. Whenever you have a Docker image, right? There are various places you can deploy this Docker image. As I said, you can deploy it to Elastic Beanstalk. You can pull it on an EC2 machine and run it there as well. But one of the best things you can do, if you know you have a container, is use something called container orchestration. What does container orchestration means? It means कि यार समझ आ गया ना कि this is a container. It is present at 100x devs/landing. The developer or the DevOps engineer, let's say, just needs to specify that we need 3 such containers running. I repeat, the DevOps engineer just needs to specify this number of instances we need of this specific image, and the container orchestration engine, Kubernetes in this case, will itself figure out 3 machines, let's say, or 2 machines where it will deploy 3 such containers. What does a container orchestration engine do? It orchestrates these containers on various machines. Can you orchestrate them yourself? Yes, I could totally create an EC2 machine, SSH into the EC2 machine, and run the command docker run -p 3000:3000 and then the image name. I can totally do it manually, but this is where orchestration comes into the picture. Okay, I as the developer only need to tell the number of containers that need to be running, and someone else takes care of bringing them up in case any one of these containers go down. That same orchestration engine brings it back up. I just need to tell it the number of replicas, the number of times I want this specific container to be running. That is what Kubernetes lets you do, or even other, container orchestration engines. In Kubernetes, you first create a Kubernetes cluster, which means you basically create a bunch of machines that are connected to each other. And you tell this Kubernetes cluster, hey, please deploy 100x devs / landing and create 3 copies of this. You create what's called a deployment. This deployment, the first jargon you need to know if you're learning Kubernetes, maybe not the first one, but a jargon you need to know. You create a deployment, you give it the number of replicas you want. This is one thing you give it. You give it the image that you want to be deployed, and then Kubernetes takes care of deploying it in 3 different places. What is the first thing we will be creating? We will be creating a deployment. The second thing we will be creating is something called a service. Whenever you are deploying an application on Kubernetes, it is not by default exposed over the internet. If you do want it exposed, you have to create a service. Service can be of many types. We'll probably just create a simple load balancer service and call it a night. But ideally, you probably want to use something called as an ingress. If you really want certificate management out of the box, if you want to host multiple applications on a single load balancer, you should be using an ingress. But today, what are we doing? We're keeping things very simple. We will be focusing on creating a deployment and creating a service. What does a deployment do? It will start multiple containers of mine in my Kubernetes cluster. What does a service do? The service will expose them over the internet. Maybe towards the end of the video, I'll show you my current setup. How and where do I run my Kubernetes cluster? I do use an ingress. How do I deploy? Whenever I have a new application to deploy, for example, the one that we're deploying today, how do I deploy it? How many steps does it take me? How many files do I have to create? How many commands do I have to run to deploy one new application, let's say this landing application, to my Kubernetes cluster? Let's get into the easy bits. Let's create a Kubernetes cluster. Let's create a deployment. Let's create a service. Let's expose our application over the internet. All right, let's go through the easy way to deploy an application. We'll keep things simple and straightforward here. This is the easiest way to deploy, a full stack application that needs to be internet facing on a Kubernetes cluster. Then we'll go through the slightly harder way. And this is what I'll be using finally in production as well. But before we reach here, let's quickly understand the most basic way to deploy an application on a Kubernetes cluster. Step 1 is just creating a Kubernetes cluster. Think of this as being very similar to you creating an instance on, let's say, Amazon or GCP. Step 2 is creating the deployment. Given that you now have a bunch of instances, how can you deploy your containers on those instances? A deployment lets you do that. Creating a service. Given that you have containers running on your machines, how do you expose them over the internet? You can create a service of type load balancer, which will pretty much create a load balancer for you. That is going to, route requests to your final containers. And lastly, add a CNAME record in domains.google.com so that the final application is hosted on, next/6.100xdevs.com. Let's go over all of these steps one by one. Step number 1 is creating a Kubernetes cluster. You can create it anywhere, be it Google Cloud, Amazon, Vultr. Let me quickly take you through the easiest one, which is going to be create one on Vultr. You sign up on this platform. You see this section called Kubernetes. You click on add cluster. You give your cluster a name, for example, next-4. You select a region where you want to deploy your cluster, let's say Delhi. You select the number of machines in your cluster, let's say 2, and you click on deploy. Once you do, you will see a Kubernetes cluster created. I just created this like 5 minutes ago. This is also an empty Kubernetes cluster. If I click on it, you will see it lets me download configuration. This configuration is what I need to connect to my Kubernetes cluster. What did we say a while back? We said that we need to create a deployment, create a service. To be able to do that, we need to be able to talk to this cluster. You can do that by, using this configuration file. Now, one big assumption I have in my mind is that you've already installed, you've worked with Kubernetes, you know what kubectl is, and you already have it installed on your machine. If not, please install kubectl on your machine before proceeding. I have the configuration downloaded. Let me open it in Visual Studio Code. Let me copy it and let me paste it in. .cube/config ~.cube/config is where I'm going to paste this configuration that I got from Vultr. I downloaded the configuration, opened it up in Visual Studio Code, copied the whole thing and pasted it where? In cube/config .cube/config in my root folder. If I now run kubectl get pods, you will see it shows nothing is running. Here, what is a pod? We'll get to it. Run kubectl get nodes. It shows me, Harkirat, you are running 2 nodes in Vultr right now. I repeat, what does kubectl get nodes tells you? It tells you you're running 2 nodes in your Kubernetes cluster on Vultr. Now my kubectl, my Kubernetes CLI is connected to my Vultr Kubernetes cluster. What do I have to do next? What was step number 2 after creating a cluster? Step number 2 was creating what's called a deployment. If a deployment sounds super fancy, which probably it does, you can simply create a pod rather than creating a deployment. This will make your life slightly easier, but this isn't something you should do in production. Why, Harkirat? Long story short, a deployment, when you create, you tell it the number of containers that you want to run. For example, I want 3 containers running because I have, let's say, a lot of people who are, going to be hitting my application. Whenever one of these containers goes down, the deployment makes sure it comes back up. If this number becomes 2, the deployment will make sure the number of pods increase back to 3. Versus if you're just using pods, if a pod dies, it dies, no one restarts it. That's the reason you might want to use a deployment. You can also use something called as a replica set, but let's not go there. High level, long story short, a deployment creates a replica set creates a bunch of pods. You can simply create pods, or if you want, you can create a replica set, or if you want, you can create a deployment. That's as much detail as you need to know. If you don't know Kubernetes, this is really hard. If you do that, it's straightforward. Either way, let me proceed. Let me create a folder in Visual Studio Code in next frontend. Let me call it ops. Inside ops, let me add a deployment.yaml file. This deployment.yaml file is where I'm going to be writing my Deployment specification. The good thing about Kubernetes is whenever you want to create these Kubernetes objects, right? When I said I want to create a deployment, I can simply write in a specific file, okay, I want to create, a deployment which is present in the V1 version of Kubernetes. And then you can just, use AI to write a bunch of code for you. What does the code say? Okay, I am creating a deployment. This is the metadata for the deployment. Let's see, that looks pretty wrong. This next-app-landing. I'm going to create 3 replicas, let's say, or 3, copies. This is going to be the layer. Don't even worry about what this is. This is going to be how the deployment knows whether a specific pod it owns or not. If you don't understand this, it's fine. Ignore this jargon. Template, any pod that this replica set starts, or this deployment's replica set starts, needs to have these labels, which is app is next-landing, and this is the final specification. The image that we're running is 100x devs /landing : Linux. Ports 3000 is where the application runs. Resource, these are the requests and these are the limits, which means, let's increase the limits a bit. And the requests are, minimum 100 mini cores need to be present, which means, 1/10 of a core needs to be present or reserved for this specific container, each one of these containers. This very long file, I know it's jarring, especially if this is the first time you're doing Kubernetes. But this very long file is my deployment specification. It is telling my Kubernetes cluster, I need 3 replicas to run the 100x devs /landing image inside this Kubernetes cluster. That's all that this specific deployment.yaml is doing. If I run the command kubectl apply -f deployment.yaml, it tells me API version is not set. If you choose to ignore this, there's a typo in API version. Let's try that one more time. I think this is apps/v1. Let's try that one more time. And it says deployment created. Now if you run kubectl get deployment, it shows me a deployment is beginning to start. If I run kubectl get replica set, it shows me a replica set has been created. If I run kubectl get pods, it shows me 3 pods that are starting. These 3 things that you see here are in fact, if these are the 2 machines that you have, these are 3 containers that are starting, in some of these machines. In this case, they'll just start on 1 machine. But if I had a bigger Kubernetes cluster, they would have started, 1 over here, 1 over here, and 1 over here. Right now, since we only have 2 nodes, and one of those nodes is going to be what's called a master node, all 3 containers are going to run on this second node that we have. Let's wait for a few more seconds for our application to run. Again, the application is running. It is not yet exposed over the internet. We'll be going through how to expose it over the internet when we go through step number 3. On step number 2, we have just created the deployment. We have just deployed 3 containers, or more specifically pods, in our Kubernetes cluster. Let's wait for these to begin running. The current status is container creating, which means they're probably pulling the container, the Docker image, and trying to run it on this specific Kubernetes cluster. But if you wait a while, now as you can see, the status of all 3 of these is running. If I run kubectl logs -f one of these pods, it shows me the right set of logs. It probably means we have 3 containers running in our Kubernetes cluster. What do we need next? We need to expose them via a service. So what is the next thing we will create here? We'll create a service.yaml file, which again is going to have API version, no idea, kind, service, metadata, next-landing. That's the name of our service. specification, any pod that has next landing as the app, expose it on port 80, target port is 3443, and the type is going to be load balancer. The only other question is what is the API version of a service, and I think it is v1. If I apply service.yaml, it says service has been created. What have I done over here? Just how I wrote a very big file that told my Kubernetes cluster, okay, you need to now run 3 pods, or let's say containers, of this specific image, and my Kubernetes container started to run them. Similarly, I've created what's called a service, which will just create a load balancer outside the Kubernetes cluster, and any incoming traffic on this load balancer will get routed to port 3000 of any pod that has this metadata associated. I repeat, any pod that has app set to next-landing. If I go to the deployment, what were the labels on the app? The template said I'm going to attach app next landing as a label to every pod. If I do a kubectl get pods and I try to describe one of these pods, this pod, if you look at the labels, has app set to next-landing. And this is how we tell our service, this is how we tell our load balancer, okay, hey, this is how you can find, or where you can find, where to route the traffic. If any traffic is coming on port 80 on the load balancer, send it to port 3000 of these pods. So in the end, what would happen is, step 1, you created a Kubernetes cluster that created 2 machines. We just saw that in Vultr. Step 2, we created 3 pods. We created a deployment which created 3 pods of our NextJS application. And lastly, we created a service which is going to create a load balancer which will route all the traffic to these 3 containers that we have started. Let's go to the Vultr dashboard. I repeat, let's go to the Vultr dashboard and let's look at the load balancers section right here. Can you see a new load balancer is being created? Yes, Harkirat. Did I come here and added a load balancer? No, Harkirat. Then how was this load balancer created? This was created because I applied this service. I created a service which was of type load balancer that automatically created a load balancer here in Vultr. If I did the same thing here in AWS, a load balancer would be created here in AWS as well. In fact, this is my Kubernetes cluster in AWS, the prod one. And if I go to EC2 and load balancers, you will see there's a load balancer running outside the Kubernetes cluster here as well, because my main Kubernetes cluster also has a load balancer service. Let's wait for this to finish. And once it does, hopefully any request that I sent here should get routed to the container. If this wouldn't have failed, now that this has failed, our life is going to be a little hard. Let me debug this. Now it is running. Never mind. Let me open the load balancer. What did we say? Any request to this load balancer on port 80, let me send it, is going to the 3 pods. I repeat, any request to this load balancer on port 80 is getting routed to these pods, which is why when I go to this specific load balancer, I see, the final website. These pods are running the 100x devs. What are they running? They are running the 100x devs / landing image, the image that we just created a while back. What was the image that we just created a while back? What did we push to Docker Hub? We pushed this 100x devs / landing image. And this image is what we have pulled to our Kubernetes cluster. Again, what does our Kubernetes cluster have now? Our Kubernetes cluster has 3 pods running. How are they running? They are actually running through something called as a replica set. How is this replica set created? It was created by the deployment that we created. So we created the deployment created the replica set created the pods. And the other thing that we created was a service, which is this next-landing service, which is a load balancer. This is the IP, or more specifically, this is the external IP. If I go to this external IP, I see my website. Can I attach it to my domain now? Yes. If I go to domains.google.com, go to 100xdevs.com at the very end, click on DNS, click on manage custom records, add an entry to week dash or whatever next dash 5.100xdevs.com, a record that points to here. If I now go to next dash 5.100xdevs.com, you will see it routes over here. Can I attach an SSL certificate to it? Yes, I can. I can just go to, the Vercel load balancer and attach an SSL certificate over here. But is there a better way to do this? And yes, there is. It's using ingresses. I think it's out of scope for today. But here are the steps that I would have used, or I will probably use towards the end of the video, to deploy this application to my real Kubernetes cluster. My real Kubernetes cluster hosts a bunch of applications. It hosts app.100xdevs.com, projects.100xdevs.com, algo.100xdevs.com. It totally makes sense for the landing page, the thing that we are creating today, which is going to be 100xdevs.com, to also be hosted there. Hence, eventually, I will be doing this. Eventually, I will be not creating a Kubernetes cluster. I already have it. I will be creating a deployment. I will be creating a service. The type of the service will be slightly different this time. I will be updating my ingress. I already have one. I just have to update it. I will be adding a certificate and lastly updating the DNS record. This is how I will eventually deploy this in production. But let's not go here. I hope you understand the high level of Kubernetes and how you can deploy your application using it. This is how I would deploy it if I have a lot of services, if I have a very big team. I wouldn't do this if I have a single application, but Kubernetes is actually pretty cool if you understand it well. And it takes down your deployment time by a lot. The whole containerizing your application and deploying it architecture. You don't take your raw code and deploy it on an EC2 machine. You containerize it first, push it to Docker Hub, and then pull it somewhere. Has long term a lot of effects. It makes your dev speed much faster. For example, if this is a project I have to deploy, it will take me less than 5 minutes to deploy it in a scalable way in my Kubernetes cluster, versus if I was deploying it on a raw EC2 machine, I would just have to SSH there. If it goes down, it's a mess. Right now, if this Kubernetes cluster goes down, or if I delete one of these pods, even by mistake, if I do a Kubernetes or kubectl delete pod ID, you will see the pod died, but another pod restarted. As soon as the pod died, another pod restarted. There's something looking at these pods and making sure 3 are always up. As long as this number here is 3, 3 pods are always up. This is what Kubernetes provides you. And this is really hard if you're not using some orchestration engine that's taking care of pods when they go down. You need to have an auto healing system. Even if you're sleeping, if a container goes down, it should be able to come back up. If I change this image to be something random, right? If this is a random image that I choose and redeploy my application, if I do a kubectl apply -f deployment, the system should be auto healing. If I see all the pods, you will see my existing pods are still running. Even though the new pod is beginning to crash now, the existing pods are still running. This is how your system should be. It should be auto healing. Kubernetes provides that out of the box. That's all I'll speak about on Kubernetes. Next up, let's move into some dystopian scenarios. Let's deploy this application on a decentralized compute platform. Very dystopian. All right, how many of you have heard of AkashNet, or what do you understand when I say decentralized compute? It basically means that currently, AWS is a very big company, GCP is a very big company, and they sort of have monopoly over, the cloud market. Even though so many people all around the world have machines. These are just two big companies. If this is the world map, there are thousands of people who have a lot of compute at their disposal, right? A lot of people have a lot of machines. What if they could rent out a portion of their machine? Or what if, if there are big providers on one side, small providers could also come and bid, okay, I am willing to give you my compute for the next 1 month for just $1. What if there was a market where people could come on both the sides, and you could see there is one side that wants to buy compute, there is other side that wants to rent out compute, and you could just rent out someone else's machine in a decentralized fashion. What do I mean by decentralized? I mean, no government can come and tell, well, if I'm being honest here, a government can tell. This machine in the end has an IP the government can track. So, let's not get too ahead of ourselves and say this is completely decentralized. The bigger thing that a network like Akash network provides you is, a market for you to rent machines and a market for small providers to rent out machines, and, have a competitive market where people can buy and sell servers, or rent servers more specifically here. That really is the only thing it provides right now. Does it really provide decentralization? I would assume not. If the government wants to block one of these services, they can probably send a cease and desist and, turn down a server. Either way, let's look at what it says. It says, number one, if you want to deploy an application to this cloud provider, again, Akash.network isn't really a cloud provider. They don't have machines of their own. They let anyone come and put their machines for rent. They let other people, application developers like us come and rent those machines. After you sign up here, firstly, to be able to sign up here, you need a wallet, and you need some money in it, of course. This wallet is called 𝗟𝗶𝘀𝘀. It's on Cosmos, which basically tells me that AkashNet is, a blockchain of its own, because Cosmos lets you create, blockchains. Probably makes sense for this to be a blockchain of its own. I have 2 AKT tokens which are worth $6 right now. And if I go to the deploy section here, I can, deploy either a Hello World application, a simple NextJS application, or my own NextJS application as well. For example, if I want to deploy a Hello World application, it shows me a very long, spec file. And notice, it looks very similar to a Kubernetes spec file. It creates a service, creates a deployment. And this service, if you look at it, exposes everything on port 80, goes to everything on port 3000 on this specific image. Let me replace this image with my own. What was our image name? It was called 100xdevs / landing:/Linux. This was our image, right? What if I apply this spec file? If I click on create deployment, again, what am I doing? I am again creating a bunch of YAML files, very similar to Kubernetes YAML files. And what am I saying? Okay, this is the image we want to deploy, and expose this on port 80. Whatever is running on port 3000 on this image should be exposed on port 80 on the final load balancer machine, whatever. When I click on create deployment, it asks me to pay some money. If I click on continue over here, thankfully I do have, whatever, $1, which is what they require. If I approve this specific transaction, wait for it. I can select one of many such bids. The cheapest bid that you can see over here is just for $0.57 or even $0.51 a month, but the uptime here isn't the best, which is why I would probably go with this provider. It's not audited, which, if I'm being honest, is fine for this landing page of mine. It is fairly cheap, and it has 97%, 99%, 100% uptime. So I'm just going to choose this one and click on accept bid. And now for the next 1 month, I only have to pay $0.57 for this landing page to be up on a half a core machine. What was my specification? My specification was half a core. It's a small machine. If I have a lot of traffic, I will of course need to upscale this. But if I have a very simple landing page, what's the cheapest DigitalOcean machine? It's $5 a month. What's the cheapest AWS machine? Again, probably $5 to $10. But here I can get some very small compute in someone's data center for less than $1 for the complete month and deploy my simple landing page over there. Even if it was a mildly complex application, NextJS application, doesn't matter, I can still deploy it over there. This is the biggest benefit of using containers. It just gives anyone, a way to create systems like these, because an image in itself runs independently. Anyone can run an image, a container. It has a file system. It has all the dependencies that you need to start it. And, it lets platforms like these be built. If containerization wasn't a thing, then, I would have to tell them, first install Node.js, then start the application by running npm run start, so on and so forth. But if I have a container, I just have to tell them this is the image that you need to start. They start it and then you're good to go. Let's see if this is deployed. Seems like it. I see my logs. Let's go to my deployments. This one right here, URIs. And as you can see, my application is hosted on some weird url.ingress.some weird url.cloud. I can always replace this with my own URL, add a CNAME entry. If I want an SSL cert, I'm sure Akashnet provides you that. As you can see, it's really slow though. I don't know where this image is coming from, but yeah, it's slower than what I've seen on AWS. Doesn't matter either way. It's like a very cheap machine compared to AWS as well. And as I said, these systems are fairly immature. Pick and choose if you want to do this. The best part of this is, you don't need a credit card. You need something worse. You need a wallet, and you need some money inside it, which is probably harder to get than a credit card right now. But if you have $1,000 and you want to get away from all financial systems, move away to an island, those $1,000 can last you a long time, and you can always keep on deploying applications on the internet anonymously. If your wallet is anonymous, you can also deploy these things anonymously. That's also a pretty big thing. You can probably do that in AWS as well, if I'm being honest. Who's checking? But you get the idea. You get why this system might be big. I'm not saying it is, but Akashnet, if you look at the token, it's closer to $1 billion in fully diluted market cap. So you never know. That's it for decentralized frontends, or more specifically decentralized compute in this case. Pretty ambitious problem to pursue. I like what these guys are doing. So I'm excited to see if it becomes a norm. I think distribution is the biggest problem right now. Most people don't even know there's a thing. Then there is so much friction. Okay, first get Kepler wallet, then get Akashnet token, and only then can you deploy. There needs to be a Web2 system built on top of this that creates a very simple Web2 interface to in the background use something like Akashnet to deploy your applications. That's all for this section. Lastly, let's move to an open source version of Vercel. I'm very sleepy, so there's a very high probability we don't completely do this. We will at the very least look at it and understand why there is a need for it, what does it do, and why you might want to use it compared to the other things that we've discussed. Let's get into the next section. All right, last one for today. We're going to go through Coolify. Coolify is, well, their pitch was open source Vercel. If you look at their code base, they are open source, and they do provide you everything Vercel does. That includes deployments as well as direct integration to GitHub, and you can self-host it. If you look at their star history, look at that. They suddenly became very popular fairly recently. I heard about them around the time when I released the Replit video, which would be March-ish. And then, suddenly, as you can see, they've been catching up a lot of heat. Why would you want to self-host Vercel? Vercel does give you some benefits, right? Specifically, a UI to see all of your deployments, track if anything went down, things like these. Coolify gives you the same thing at, no price, because you can self-host. We will not be self-hosting, even though I would assume self-hosting it is not too difficult. They have some sort of, setup procedures, hopefully containerized, maybe not containerized. They probably need to run directly on your machine. I don't know. Either way, yeah, there you go. You probably need to run this, and that should install Coolify on your server. I am going through their paid offering. They do also have a paid offering. They're also a company, and I'm going to pretend here, okay, I want to support the company. Hence, I went through this, and not the fact that I'm very lazy and it's fairly late right now. The only thing I've done until now is gone to the website, found their paid offering, and paid like $5 for it. I don't know if this is completely managed. I don't know if, just like Vercel, they will just handle my deployments for me, or if this is something else. So I'm just going to explore this with you. Let's click on get started right here. Next, I do not have an SSH key. Let's say it creates an SSH key for me. It asks me to put this in ~/.ssh/authorized keys. Okay, so I still need to have my compute. They will just probably, deploy a dashboard on top of it. I still need to have my compute where, my final applications will be deployed. This is a server that I just started. It is running. Let me connect to it. cd.ssh authorized. Is it authorized or is it author? Might already be there. Authorized _ keys. And I'm going to paste the Coolify, like this key that gave to me, to my authorized keys. This way, Coolify can, SSH into this server of mine and probably deploy the applications. Should I back this up? Maybe. Save. Create a server. Please let us know the server details. Name, AWS, IP address is this thing right here. Port, root, continue. Validate and configure server. I need to validate the server connection, Docker engine, etc. and configure if something's missing for me. Are you okay with that? Let's do it. Server is not reachable. Please verify the configuration. Here is the documentation. Root. It's not root. The username is Ubuntu. So can I go back? All right, IP address is this, port is 22 and the user is Ubuntu. Let's see. IP address is used by another team. I am the same team. Oh God, I'll have to start this again. All right, they have a lot to do when it comes to the paid onboarding. It's fine. I think this is a one-person team, which is actually super commendable. Would have been nice if I was able to see a demo. I'm not in the mental state for it though. It's 7:31 p.m. Video was supposed to be released at 6, so we're late by an hour and a half. This is probably where we'll have to cut off Coolify. I'm sorry if you saw the thumbnail and felt like we're going to discuss Coolify, but I'm happy to do a tutorial on it. I've just seen this project, from the top, and from first principles. Super excited to dive into this generally. There are decent amount of bugs to be fixed, in their managed offering. I'm sure, there's a few things here as well. Either way, I think we'll call it here. One last thing I should probably do is actually deploy this to 100xdevs.com. There is a website of ours that, we want to replace this landing page with the landing page that I just created. As I said, I already have a Kubernetes cluster. So let me quickly go and show you how I would deploy this. I created the detailed steps a while back. Let me quickly show you them one more time. The way I would actually deploy this on a Kubernetes cluster would look something like this. Create a Kubernetes cluster. I already have it. Create a deployment. I will have to do this. Create a service cluster IP. I will have to do this. Update the ingress. I already have one. I'll just have to update it. Add a certificate and then update the DNS record. Shouldn't take more than 5 minutes. The real deployment, how much time this video should have actually taken, is I think less than 5 minutes. So let's quickly go through, how I deploy an application. Whenever I have a new website that I add, how much time does it take for me to deploy it, and what are the steps that I take? All right, this is the repository where I store all of my Kubernetes manifests. As you can see, there's one for algorithmic arena, everything that you see over here. a subset of everything that you see over here is what hosts this website. Similarly, there's one for CMS, one for daily code, one for Exchange proxy, some side projects, some main projects that I have. I'm going to introduce a new project here called landing, which means the landing page. I'm going to create a deployment. That's the first thing that we were supposed to add. If I go back here, what is the first thing that we need to do? Create a deployment right here. Let me do that. API version app/v1 kind deployment, name landing, labels landing. Everything else here is fine, other than the fact that the image that I'm using is 100x/landing:linux. Container port is 3000. That's what my deployment should look like. It looks pretty good to me. That was step one. I still need to apply to my cluster. We'll apply it in a while. What's step two? Step two is creating a simple cluster IP service. Let me do that next. Target port 3000, port 80. That looks right. Type cluster IP. If you wanted to do this from first principles, or not even first principles, just some trial and error, you could have looked at, a deployment for a different app and then a service for a different app. You'll see they look very similar to what I'm creating over here. Lastly, what is the third step? We need to update the ingress. So if I go to algorithmic arena/ingress/ingress.yaml, here you will see I have a bunch of TLS entries to begin with. I need to add a new entry here for the root domain, that's 100xdevs.com. That should point to landing-TLS. This is a secret where I'll be storing, my final certificate. How do you do that, Harkirat? We'll get to that very soon. And lastly, a request that's coming to this host. If there's a request that comes to 100xdevs.com, it should go to the service that is called landing. This was the service that I just created. Any request that's coming from this specific host should go to that specific service. What steps are we done with? We're done with creating the deployment, creating the service, updating the ingress. We have to create the certificate. That's the last thing I have to do. So if I go back to landing, I have to create a certificate.yaml, which the kind would be, would it be a secret? No, I don't think it'll be a secret. It'll be PI version cert manager, create a certificate. Let's call it landing cert, namespace default, secret name, landing TLS. This is the same as what I should put in ingress right here. That looks right. Issuer, let's encrypt prod, and 100xdevs.com. That looks right. The only other thing I have to do before I apply this is update, my DNS entry. So if I go to domains.google.com, so look at it. Now hopping on to the last step, which is updating the DNS entry, and then I'll just apply all my manifests. Manage, there will be a very big problem here, which is that you can't have a CNAME record at the root level. This cannot be a CNAME. This is where I need to point it. This is the load balancer for my Kubernetes cluster. But if I try to save this, I'm pretty sure this will not work. You cannot have a root domain CNAME. So I'll have to add a hack here for now, I think. Yeah. Cannot add a CNAME to a root level domain. This is what I was worried about. For now, I'm just going to do this. Get the IP of the load balancer and put it here. I'm not sure if this will work basically, but yeah, rather than adding a CNAME record, I'm adding the IP of the load balancer, which is not the best idea because the IP might change. But theek hai, vball for now, 100xdevs.com. The DNS entry hasn't changed, might take some time for this to propagate. While this is propagating, let me apply all the manifests. Let me go to Visual Studio Code. Let me go to the landing folder that we just created and do a kubectl apply -f deployment.yaml, and it says I cannot connect to the Kubernetes cluster because this is my Vultr cluster that I shut down. I need to re-update my Kubernetes config, cp kube/config-aws over to kube/config. Let's try that one more time. Deployment has been applied. Service has been applied. Certificate has been applied. And the ingress is the last thing I need to apply because the ingress has been updated. If you remember, I updated a few things here, right? I updated 100xdevs over here. I added the TLS entry. I also added, if any request comes to 100xdevs.com, it should reach this specific service, and hence I need to apply the ingress as well. That's it, guys. The only thing I have to do now is keep polling the certificate and make sure the certificate is, issued. If you look at it, landing cert isn't yet issued. This is false. I'll have to wait probably a long time for this one, but we'll see. Let's wait for a few more minutes. Okay, well, that's not too bad. That was a little too quick, if I'm being honest. Well, there you go. We've been able to deploy to 100xdevs.com. I don't know if we had a timer, probably less than 10 minutes. There is just one problem here. Root level domains where you will have this problem. If you're ever directly deploying to 100xdevs.com, you can't add a CNAME entry. There are ways to get around this. If I move my domain to AWS, I think I can do it. But for now, this works. If this load balancer IP changes though, then I'm screwed. And people will see some random shit here. But for now, this is great. 100xdevs.com is now pointing here. And if you go and pre-register, since this is a NextJS application, it will indeed register you. The only other problem is, I have to keep pulling the logs now. If I go to kubectl get pods, you will see I have, this landing pod running. And if I go to kubectl logs of this landing pod, you can see the first email. I just need to make sure these, this pod persists, this log stays, else so many people will register and all of their emails will get lost. I should also just stash these logs somewhere. But that's a story for another day. Hopefully this video was insightful. Let me know what's your favorite way to deploy your application. Mine these days is this. As you can see, dude, it just scales very well. If I want to just, if I'm anticipating a lot of load, I can just increase the number of servers. It's just it's just the smoothest way to deploy, in my opinion, is just get a Kubernetes cluster. It's an uphill battle initially, but once you understand it, I think there's a lot of upside to doing something like this. This isn't even the tip of the iceberg. If you're using Kubernetes, you can do a lot of things. You can use GitOps. You can have a repository that's directly synced to your Kubernetes cluster, yada, yada, yada. But we'll get there when we get there. That's all I had for this one. I'll see you guys in the next one. Bye-bye.